books from research community. There are more than 3 lakh books available on our online platform, which is springerlink.com. We'll talk about it also. This is a platform where you will find everything available online, and that has actually saved us during this huge problem or challenge of pandemic, because anything online which was available, which is accessible, and people were downloading, people were reading, people were using them. Pioneers in digital publishing. So we started long back in 1995. We started with all the publishing of articles online, and then in 2005 onwards, we for the last 15-16 years we are doing it for books. So any book which is published with Springer is published online first. So that is one of the things which has actually saved us. I'm saying this again and again because this is a platform which has really helped us to stay alive with the community. Now, why publish a book? It's an interesting question. There are many answers can be there, but I will just talk about two things over here. Number one is, firstly, you conduct the research for yourself. When you start thinking about a research, you don't think about any other things. You try to, solve the queries which are there in your mind. You try to get solutions, which the questions which are coming to your mind, and this is the query solving sessions for yourself. And this is how you come into research. You try to do research for yourself. But when you write and publish, that is what exactly when you work for others. When you take this particular research to a different level, and then you enter the community, and people can actually read your thing, and they can get help from that particular content. Connect with the community is something which is important. That is the benefit of book publishing. That is very, very important. When you publish a book, you get connected with the community. It builds your reputation. People who have published book, they know very well that how it builds the reputation with among the scientists. And it accelerates your career. This is a most important thing, because everyone looks for growth. Everybody wants to grow in life, and research is something which is ever growing. So when you write, when you publish good articles, when you write a good book, then it helps you in acceleration of your career. There are 5 steps. I will just talk about these 5 steps, how you can actually publish a book. I felt it is important because many of you are ready to write a book, many of you are planning, contemplating, but at the same time, you don't know where to approach, how to create the proposal and all. First thing is, it starts with an idea. It comes to everything starts with an idea. So whenever you have a good idea or a unique idea, please write it down, because we get plethora of ideas in a whole day. Every day we get these numbers are growing each day, but we don't remember them every time. When you have a very good idea, when a person has a good idea, then you can create something new, something novel for the future researchers. But when you have a unique idea helps you to fill the gap in current literature. Now, what exactly is current literature? Gap in current literature means, when we talk about artificial intelligence, which is the most most popular topic for last 5-7 years. Every field is talking about artificial intelligence. But artificial intelligence started long back. It started in 1960s. Then 60 years ago the term was coined, and it has a literature of 60 years. But definitely in those 60 years there will be many gaps. So if you have a unique idea which can fill those gaps, then it is a fantastic thing. That actually helps the community to grow. That actually helps a good book to flourish. Now, when you have an idea, now this idea needs to change into a proposal. That is very important. And how you can change it to a formalized into a proposal. The few things we need as a publisher from a book author, and what all these things, you need to have a curriculum vitae. There is a CV, there is the biodata of the person with the list of publications. It never matters whether it's a small number of publications or a very huge number of publications, but it really helps to understand what kind of publications you are actually doing. Synopsis of the book, this is the most important thing. I think everybody fails to write in the beginning, because whenever I ask for a synopsis of the book, 80% proposers, they write the synopsis of the subject. They, if it's a book on applications of machine learning, then I need to know what exactly you are actually writing about in your book, and what all things as applications you are including in your book. And I don't want to know anything about machine learning as a whole. But most of the people, they write a 2-page 3-page synopsis of the book with most of the things about the subject rather than the book. So important thing is you should write what is the content of the book, what exactly it represents, and what are the benefits to the readers. That is the small part in 150 to 200 words. Then comes table of contents, the structure of the book. And finally, the sample chapters. This is very important, because when you present the sample chapters, then it gives the reviewer, the person who will check the proposal, the kind of, the objective which you are going to handle, and what all exactly is there in your chapter, the language, the clarity, everything comes, understanding comes from there. So these are the 4 things which you have to add and which you have to include when you are creating a proposal from an idea. Once you created this proposal, the proposal goes to the publisher. Whosoever is the publisher is first, they do a proposal evaluation. The evaluation, the first entry, it is like, first entry thing. We will check what all things are there, everything is in correct order, so that we can send it to the reviewers for peer reviewing. Peer reviewing is, you all know, it is basically going to an expert in the field or the people who are working in your area, so that they can give comments about that proposal. Once the peer review is done, then it is acceptance and contracting. Contracting is a formality, which is basically a legal formality which happens between the editor, authors, and the publisher. Then once the contract is done, you get an author package. Author package is nothing but the templates, copyright forms, permission forms. These are different instructions. They come as an author package to you, and then you create the manuscript according to this author package. So finally, you get to the manuscript. And once the manuscript is ready, in the 4th step, you submit this manuscript to the publisher. Once you submit this manuscript to the publisher, now we publish the book in different formats, like not only in the print format, but also in different online formats. Format for iPad, format for Kindle, format for any kind of smartphones. So what exactly we do, we take the manuscript, which is in always, we prefer to take uh, online manuscript, and it is a soft copy always. And this soft copy is basically tagged into XML. XML is the most core thing which is created first, and from XML we start creating all different kind of formats. So production team, they work in tandem with the author or the editor for almost 10 to 12 weeks, and then they create this format, and these formats are out and they come as book. The final step is basically by the publisher, not by the author or editor. It's basically how we share this whole thing with the world. But at the same time, you can also share your work with the whole world. That is the most important thing, because when you start sharing your work, then only it grows, then only it gets observed, then only it gets cited. So there are certain websites, I will just talk about them quickly. First is springer.com. Springer.com is a website where the book, the dedicated homepage of the book is there. So whenever you write a book with us, the sales information about the book, the ISBN detail, author details, about the book details, and all these things, they will be there on springer.com. Then we have another website which is called springerlink.com. Springerlink.com is the content platform where actually the content is available. And we have 10,000 plus institutions. They are member of this particular platform. And these institutions, they usually come and purchase the books in the form of packages, like whether it's a package of computer science or whether it's a package of electrical engineering. And also these packages, they contain the book. So we always, put the book in the packages correctly, so that it is picked by the correct readers. Then we have distribution. Distribution is not only through Springer, it is done through third parties also. We include Amazon, we include iTunes. Now Flipkart is also a part of it, Barnes and Nobles, there are many, and they do the distribution. You can buy from their platform also. And finally, there is a team which is working as an author support team, which creates covers, which create flyers, which create newsletters. Flyers are something which is a one-page document, which is a PDF, which is available on springer.com. That is the homepage of the book. And you can actually download that flyer and you can send it to anyone. They can read it. So you can send it online. And newsletters are something which we are creating, every fortnight, and we are sending it to people, sending it to the communities, and we are also distributing it in different exhibitions where people can see them, people can read them, and people can know about the new publications. So these are the 5 steps, which are the important 5 steps for publishing. So it starts with an idea, you formalize the proposal from to the manuscript. Manuscript is to becoming a book, which is in different formats, and finally the distribution of them. Now we will move to the next section, that is types of books and services. It is important to know the types of books, then only you will be able to write them correctly. And we will talk about very few services at the end. The first thing is monograph. Monograph is a scholarly book. It is a book which is like on a single subject, written by a single author or at times a group of authors. So this is the research which you are doing can be actually changed into a particular content, which is a scholarly book. There's a saying that a scholarly book for everyone is never read by anyone. This is very important because you need to know, because I have seen many people, they write, my book is something which is for everyone. So we cannot have a scholarly book for everyone. They are basically niche topic and they are focused, and we have very targeted and selected readers for them. Second type of book is edited volume. Edited volume is a contributed volume where we have editors, and these editors are senior people in the community. They invite more contributors in their area, and these contributors, they write those chapters, and finally an edited book is created. Now there is a very big myth right now which I want to bust over here. Everyone wants to write an edited book. Recently everybody wants to write an edited book, and everybody is thinking that writing an edited book is easier than monograph. Please don't think like that. Edited books are basically for people who are very senior in the field, who can edit someone else's work. Edited book is not a collection of chapters randomly from different places and creation of a book. It's not. For random collection of chapters, we have proceedings. We have collection of academic papers coming from people for in a conference, in a congress, in a symposium, or a workshop, where you can actually submit, where your papers get reviewed, and finally we create a proceedings, as we will be creating it for ICDMAI 2 volumes. But edited book is not like that. See, when you start your career, you write original papers, you don't write review papers. Review papers are something which are written by senior people, maybe having an experience of 15-20 years in the field. They write review papers because they have the advantage of that experience. Similarly, when you write edited volumes, when someone is editing a volume, then I am emphasizing it again and again, because I have seen many people who have just completed their PhD, or maybe doing PhD, or very young research scholars. They want to write an edited book. They want to edit a book. See, this is not the time for you to edit a book. This is the time for you to write a monograph. Professional books are written for industry or commerce, usually by professional people in the corporates. They are in the form of manuals, guides, or data compendium, and many times they are very useful for people in academic backgrounds. You have textbook. You know all what exactly is a textbook. It's a course book, a formal manual instruction book based on syllabus used in schools, colleges, and universities. Although Springer is not a textbook publisher, but we publish good number of textbooks every year. That is almost 5% of this 13,000 books, which is much higher than many other publishers. Reference work is a multi-volume work, which is like an encyclopedia, where you put everything from very basic fundamentals to the very advanced stage. This is a very nice book, and we are very proud of this reference work which we publish. Then we have handbooks. Handbooks are similar like reference works, but they are always in single volume, maybe of 1200 to 1400 pages, and they are also dealing with longer entries into that. And handbooks are a pride collection of Springer. You can find many handbooks which are talking about many fundamental things, and people are using handbooks very regularly in their studies. Springer Brief is a book which I would like to introduce here quickly. It's a compact volume of 55 to 125 typeset pages. It's a very small volume. Like when you have a very big, long paper, maybe of 70 pages, an article, it cannot fit into a journal, but it can fit into as a small book like Springer Brief. It is something where copyright remains in the name of the author. It's a small, quick turnaround book, where within 8 weeks the book is out, after the review, of course. But these are the books which I think young people can write, or people who want to publish quickly, they don't want to spend too much time on writing, they can write. And these are we are publishing lot many Springer briefs now in many different series we have, and in different subject disciplines. So you can go to Springer briefs page on Springer, and you can see what all exactly we are doing over there. There is a new type of book, which is a video book, which we started very recently 2 years ago, and we thought this is something which new generation, they are very tech savvy, they study from videos, and they can do this with us. This is a book which is in the form of 30 minutes or 45 minutes, like 5 or 6 chapters, and author can come over, and he can narrate the book, he can tell the whole story over there in 5 6 chapters. And it's a very interesting platform. You can take much more look when you go into this particular platform and see what exactly we have. Very few number of books now, 200 plus odd books we have published as a video book, but it is growing, I can tell you. This is not a type of a book, but it's a mode of publication. This is an open access publication. It is always good to publish open access, because you can see over here on the slide that whatever you publish open access is 2.4% more cited, 10% more downloaded, and 10% more mentioned. But you should go to the funding pages, because if a book publishing charge is there when you publish open access, and it is not possible for you to pay that charge every time. It is not impossible. That's a good amount. So there are funding bodies, there are sponsors who can actually fund your work. So always go and check. This is the OA funding support page, which I was referring. You can go to this particular page and you can find about 200 different funding bodies. You can apply to them, and they will be helpful. In case they like your work, they will be interested to fund your work also. This is a toolkit which is very recently started, oabooks-toolkit.org. If you want to know about what exactly is OA book and what all different toolkits are available and how to publish an OA book, this is the best website, which is developed last year only, and you can take a look. This is an important thing, a good service which has started 2 years back, a reviewer finder. This has started as we find reviewers for our work, and doing it very religiously for journals and books. So this is something which has come as a tool which you can use, and you can go to springernature.com and you can take the help of reviewer finder for finding reviewer for your work. Because many journals, they mandatorily ask for reviewers. You have to give the name of reviewers when you submit a paper or when you submit a book. So you can have reviewer finder, use reviewer finder for that purpose. Recommended is another thing which is a very useful tool, where almost 2 million papers are getting published every year. That means 4,500 papers each day. So it is very important that to know when a paper related to your work is getting published. Very difficult to find from these huge numbers. So if you are a member of this particular, if you register, this is a free service in recommended, then they recommend a paper when the paper is published in your area, and this works on 45,000 different journals all across good publishers. Shared it is another tool. When you publish with Springer any paper, any article, then the production team, they share this particular link with you, shared it link, which you can share it with everyone. People can read the whole paper, and without even downloading or printing it. The whole paper is available to the person whom you are going to share your paper with. This is a legal way of sharing the whole paper. But this works in a reverse way also, which is very interesting. That is, when you want to read any paper and you see the institution has not subscribed it, and you cannot purchase a paper which is like 30 euros cost, so you can write to the corresponding author and you can ask him to share that paper with you, and legal way you can actually read it. ORCID, you all know, this is a ID. If you don't know, please go and read about it, and please register, because ORCID gives you a unique ID to you, so that you can have your citations correctly done every year without getting any kind of confusion. The Source is a magazine or a blog which is there, which is managed by Springer's author and partner marketing team. So there are lots and lots of good information is available on Source. You can go and you can also share your views on it, your point of views. So Source is a magazine which will help you to grow. Before I conclude, I will talk about 4 books over here. Quickly, I will tell about them. This is the first one is How to Write and Publish a Scientific Paper, written by Robert A. Day and Barbara Gastel. Robert A. Day is considered as father of scientific writing. He has written this book, and I always promote this book because this book talks about everything about scientific papers. So whosoever is doing research, this book is very important. You can take help. Then there is a book which is written by a publisher himself, William Germano. This is Getting It Published, talking about all the nuances of publishing. There are 2 books on ethics close to my heart. One is by Sana Lu. This is textbook of research ethics. This is Theory and Practice, which is used as a textbook in many different institutes. So you can go and read this book. And read this. Another book is by Valentina Balaz, Rajiv Dey, and Dipankar Deb. This is written by them 2 years back, Engineering Research Methodology. So the research methodology is a very important thing, in your course curriculum in PhD also. So you can go and take help from this book. So before I say thank you to all, a small message to you, a small message in the form of a quote. It says, work sincerely, focus on quality. Once you focus on quality and say no to academic corruption, there in every field there is corruption, and there is corruption in academics also. So stay away from that and stay happy and stay healthy. Thank you so much. This is my email ID, onindo.bose@springernature.com. So if you have any queries, please write to me. I will be very happy to address them. Thank you, ICDMI. Thank you, everyone, for giving me this opportunity and listening to me on this early winter morning. Thank you so much.
Thank you very much, Mr. Bose. And this would be a guideline for the emerging research scholars. And I really, really appreciate your time, as you say, in this winter morning. And we will expect you to be with us in the upcoming ICDMI events in the upcoming years. Thank you. Thank you very much.
Thank you, Anindita. Thank you so much.
So now we will move forward to our 2 keynote speakers, Professor Philip Bradford, who is the Director of Computer Science Program, University of Connecticut, Stanford, and Mr. Saurabh Mukherjee, who is the Vice President, Data and Artificial Intelligence Group, Accenture. May I now call upon Colonel Indrajit Barara to chair the keynote session. Over to you, Colonel Indrajit.
Thanks, Anindita, and thanks everyone, and to be here on the day 2 of the event, and with a wonderful talk starting with Anindita Bose. It was a good insight into the Springer, and now to take the event further, I would like to introduce Professor Philip G. Bradford. He's a faculty at University of Connecticut. He's the director of the computer science program at the University of Connecticut at Stanford. He's a computer scientist with extensive experience in academia and industry, and who could be more better than him, explaining us a keynote on a survey of naming authorities and their applications in data science. And thank you, Professor Philip, to join us all the way late in the evening there. And we are very excited to hear from you, your thoughts and your keynote speech. There are a lot of people who are asking in the chat as to when is your session, and they are looking for your keynote speech. Professor
Thank you very much. So I'm going to share my screen. This actually fits wonderfully with Anindita Bose's talk about Springer now in a certain way. So let me share my screen, and we will begin. Okay, so I want to talk about a survey of naming authorities and their applications to data science. And I want to mention this is joint work with Rachel Wright. She's been a great driver of a lot of these ideas, and I'm very thankful to be able to present this at the ICDMAI conference, and thank you for the Society for Data Science. So in this discussion, we want to talk about identity management, and this actually ties back a bit to books and music, art and authors and this sort of thing. And we'll take a peek at relational databases, and we'll use that to leverage a move towards graph databases, and we'll discuss how these constituents in different graph databases work with these graph algorithms a little bit. And so I want to try to motivate all of that. And I'm pretty excited about this whole area. So identity management is a very big field, a very varied field. So one of the most common things you see in identity management these days is UPC or UPC-A codes. And these are point of sale striped codes, as you can see in this first line. The idea is the same item everywhere in the world can be scanned right in and go into the system, and we can understand at the point of sale, we can understand what it is, and they look it up in a database and see how much we should charge and any discounts, that sort of thing. Also another big identity management type of code is the ISBN, the book numbers. These were initially produced in 1970, and later on they're enhanced in 2013 with a 13-digit ISBN number. And this is uniquely identify all books that are published. Some of the ISBN earlier ones, in fact, also include a little bit of price information in there as well for some publishers. But now we're going to shift a little bit into another area of creative endeavor, and this area is art. And this is a pretty important area as well. And so one of the big things that the Getty Foundation did in the mid-1980s, which was quite impressive, is they built the Union List of Artist Names. So one challenge you have globally is many people have similar names, or then their names may in fact in different languages be presented in different ways. And so Getty had a fairly big program that built both a data dictionary, in essence, which we're familiar with from our database ideas. So what does this particular column name mean, for example? And that would be described carefully in the data dictionary. They also built an art and architecture thesaurus, the AAT system. In addition, they put together a database of geographic names. All of these problems were targeted to deal with the art aliasing problem. That is to say, artists, when we talk about a particular artist, which artist is this, and who are we talking about? Okay, and so that was going on for a very long time, and it's still being used and built, and there's, I guess, about 200,000 fields in that database. And then there's the ISNI, which is even bigger than the ISBN. So this is the International Standard Name ID. This is for both people and organizations. So the ISBN is for books, ULAN is for artist names, and distinguishing the artist name so we can get that straight. And ISNI is for people and organizations, in particular for books, TV articles, news articles, maybe digital streaming stuff. And the idea with the ISNI, it's a 16-digit number. I have one here in red. And the first standard came out around 2012. The idea is that people tend to stay the same, their entire lives, their names are the same, everything else, but organizations don't very often. Organizations merge or they split. They are very dynamic in many natures. Sometimes they're not, but sometimes they are. So ISNI tries to help lean in that direction. And then there's another identity management tool I want to talk about, VIAF, the Virtual International Authority File. So many nations, almost all nations, really have archive and files. That is to say, they say if you go to their museums or their national libraries, they'll have lists of things that they control or have an interest in. And so VIAF actually aggregates these across the world, which is a pretty powerful tool. An example of ISNI here, you can see this red number here ends in 810. And there's some beautiful languages I have here. I just snipped about a quarter of the equivalent names for in these different languages for sort of a famous guy. This is, let's see, this is the, what's his name? It's this is I can't remember his name right now. I may have to pull it up here. Baron Kelvin, Lord Kelvin. So Lord Kelvin did a lot of great work with telegraph and things, and this is just a little snippet of what Lord Kelvin, what we equate to Lord Kelvin in many different languages. And this is a type of thing that's in ISNI. So if somebody says, who is this here that's in this particular typescript? We can look it up. And Lord Kelvin also is the Baron, and he's a bunch of other different titles he had. So this ISI has all of these things, so we can identify our friend Lord Kelvin and some of the things he wrote. He wrote many, many articles and things like that. Okay. And so there's even some more sources, and some of these even have ISO standards and things like this. And so another important one is the Library of Congress name algorithm file, which lists a lot of the things they have in the Library of Congress, the US Library of Congress. The Getty thesaurus for geographic names. Now, geographic names are special because they actually change a good deal over time and history. We can have preferred names, vernacular names, transliterations in different languages. So in one language, you call a country one thing, in a different language, you call it something else. Different dates change borders. So you may have an artist or a contributor that's in one country, but actually, he's in the country we're worried about because it rolls up into this other country hierarchically or based on the time or period in history. And there are, of course, hierarchical relationships in geographic areas. So we may be in a particular state of a particular country or a particular city of a particular state. And then there's FIGI. This is a financial instrument global identifier. So there's, in the world's financial markets, there's many countries have their own identifiers. So the standard one in the United States used to be called the QSIP, but there's a number of other financial identifiers throughout the world. And so FIGI's idea was we'll have unique identifiers for everything globally, because the global markets are, after all, largely work together, and everybody has access to those. And that's better for capital flows and things like this. One little bit thing that bothers me a teeny bit about this, so that you can see here, this FIGI symbol of 12 digits, BBG00. So FIGI has characters and letters, and numbers. But this one here, BBG000BLNQ16, actually is IBM. IBM is a big global firm, but I don't see IBM in there at all, although I realize they're a special format and everything else. But that, I guess if you see this many times, you'll see that. And many times, also, almost all of these systems are accessible on the internet, usually in RDF or in triples format or XML, JSON, and all these other good things. So we are in a great time to be able to access all of these source files or all of these name files. Now, one thing you could do with data, and I'm going to distinguish why we're going to these graph files or graph databases, is we could have, if we have a database table like you see on the right here, we have a name column, a date column, a value column, we have many, many rows, we could take the values there and we could compute a statistical distribution. This is descriptive statistics, pretty useful to help us out. If we say, what do these values look like? Well, they may look like the normal curve with a particular mean 0 and a standard deviation of 0.5. And so we know how other data points will look as they come in on aggregate. And that's fine. And another piece in descriptive statistics that we tend to work with is maybe we have two distributions. We want to see, are they the same? Or is there a high correlation? Is there an anti-correlation? So we have Pearson's R here. And we can look at this and line up our numbers and see if we have a relationship. So that's very descriptive, but that's not data science. But I'm going to get back to, I'm going to take these ideas that we just saw with these naming authorities, and we're going to try to get there. So back to our aliases, we have some of these issues I mentioned in passing. So as an example here, here's Andy Warhol, famous artist. He had a particular nationality. He created his objects in particular locations, and this actually matters. Because if you create an object or you create a piece of art in a particular location, usually where it's created is where the jurisdiction of the ownership falls or the licensing details fall. Who has the copyright? How long does that copyright last? How can you trade that copyright and that sort of thing? And of course, Andy Warhol had many other equivalent, let me call them names or aliases. So Andre Warhola, Andrew Varcola, Dorella, and many nations throughout the world, this is true everywhere I know of, in different periods of time and different periods of history have different names in different languages. They have different names for different sub-entities. Volksstadt Bayern, or Bavarian state, lasted a single year. And many people who were born there or produced art there or did something there may be rolled up into Germany, although that was actually a separate country for a brief time. And of course, we had the Federal Republic of Germany, we had the German Democratic Republic, we have Deutschland, we have Allgemein, and we have many, many different names. And then in entities, so if somebody owns art or books or things like this, usually they roll up into, or often they roll up into a company or an organization, sometimes a museum or a library. But as an example, here's some interesting companies. So the Hughes Tool Company, which was founded over 100 years ago, merged with the Baker Oil Tool Company to become Baker Hughes. It had 11 major acquisitions. It had a joint venture with Schlumberger. It did all sorts of stuff. It spun off some components in its history, and eventually General Electric bought it. Now, General Electric was founded well over 100 years ago as a combination of two other entities, General Electric, Edison General Electric, and Thomas Houston. And so those two were merged by, I think it was JP Morgan, a very long time ago, to build what is GE, or General Electric. And then there's many, many subsequent mergers, acquisitions, spin-offs, joint ventures. We had NBC, GE Plastics, RCA, which was created with them. We have Synchrony Financial and all these others. So in this case, you could build this into a relational database, but more naturally, you might want to build this into a graph structure that resembles the actual flow of the organization. So this organization had a certain flow and a certain sets of mergers and acquisitions. And many of these relationships can be described in fairly detailed ways. You can say how much of the firm is owned by one firm or the other, or what is their sale price or purchase price, or how many individuals were absorbed into the firm or pushed out. As an example, General Electric and AT&T jointly formed RCA, which is the Radio Company of America, which was a giant company and a very important company. Eventually it did go out of business over time. But then just like that, you can see Baker Hughes had its own life path. Then it was acquired, or part of it was acquired by General Electric. Then later on, General Electric sold a different part of it. Okay, and then there's other things going on here. Now, by the way, at the bottom of this, I have the ISN, the ISNI number, ISN, that for General Electric. And if you look it up, it doesn't have that extensive of a mapping here. Now, to my knowledge, General Electric is not a big art holder or things like that, but it is a big holder of other entities, and Figgy will help us handle that to some degree and other things. And the good news about General Electric is it's a public company, and many of the firms it has absorbed or sent off on their own are also done publicly. So a lot of this information is out there, and we can model this. But modeling this as a relational database can be done, but it maybe doesn't work as well, and I'm going to talk about why. And so if we have a traditional relational database, I view relational databases as wonderful for transactions and an inventory type of data. As an example here on the left, we have a table whose column names are a little bit in French, and this table can be easily represented as a graph, perhaps as a bunch of right moving arrows here and these red arrows. Likewise, on the right side of the screen, we have another table that could be a column-oriented table. And column orientation, as you probably know in relational databases, is there because we do a lot of computations on our columns sometimes. For example, we could take those values and we could do all sorts of calculations. Or maybe we have many columns where we're going to constantly do calculations. Many financial databases may be this way and otherwise. In which case, it makes sense to really have the database keyed or designed to work in a columnar sense as opposed to row sense, but that gives a certain graph representation with these columns going down, okay? So we have that issue going on, which is good, but then I want to take that idea and shift it to some graph embedding results. And so here we have Arnold Rosenberg and DeMillo, Eisenstadt, and Lipton. Rosenberg kind of started some early work in this, showing some neat worst cases. And DeMillo, Eisenstadt, and Lipton had some very nice results as well. I just want to mention one of theirs because it relates to another reason why we should focus on graph databases for data science more so than relational databases. Now, relational databases are important and they're pretty key for transactions and transactional work. So some of the topics these folks were working on is called graph embedding, and you're probably a little bit familiar with it, but I want to get this definition up because this is one kind of really good takeaway. So we have two graphs. We'll have one called G and another one called G star. And we want to say G is T embeddable in G star, okay, which we write like this. if we can find a mapping or an injection from the vertices of G to the vertices of G star, so that all edges in the original graph are of path distance, bounded by T in the new graph. So P of X and P of Y are in G star. And we want to just say, hey, the distance between P of X and P of Y in terms of a shortest path is bounded by T. Now, an example straight out of DeMillo, Eisenstadt, and Lipton is the following. If we have any K-click, and here on the left side on the bottom of the screen, we have a 5-click, okay? And so a 5-click is simply every node is a neighbor of every other node. All right, and we have a K-click where we have K nodes, and each node is hooked directly to all other nodes. And there's an embedding of that graph into the graph on the right side that is simply a node with, in this case, when we have the 5-click, we have a node with 4 children, or a very broad tree here. And the idea, and the reason that this is too embeddable is a little bit straightforward intuitively. Everything in the K-click is distance 1 to all of its other nodes. Everything in the super tree on the right side, the tree with 1 root and all the leaves, is of distance 2 from each other. So there's, anytime you're in any of the blue boxes, within 2 edges, you can get to any of the other blue boxes. So the embedding cost is bounded by 2, just by looking at that and arguing with that argument there from DeMillo, Eisenstadt, and Lipton. And now this leads to a kind of a neat idea. So here, in one of their very nice papers, they're looking at, and Rosenberg was doing the same, they were looking at n by n grid graphs. Now, n by n grid graphs are useful and important because of relational tables and how we could model these as graphs. Okay, so in n by n grid graphs, one of the nice results here in blue. So before you mention this, binary trees are very nice and very powerful tools. And one of the reasons is every node is within log n distance of every other node when you have n nodes in your graph. They're in your binary tree. So if you have a binary tree and it's a balanced binary tree, everything is within a logarithmic distance. So the key is keeping it balanced. But nonetheless, when you do have that, everything is fairly close. Logarithmically close is nice, and it's a powerful tool. And so an early result from DeMillo, Eisenstadt, and Lipton was that for any grid graph, it's T embeddable to a balanced binary tree or some balanced binary tree, then T is at least log n. So if you take a grid graph and you try to map it into a binary tree, even a well-balanced one, the mapping is going to have a distance of at least log n for some nodes. So you can't map things real closely. And that actually, to me, my interpretation of that is, look, if I have a relational table that I can model, or the relational table, for example, if we structure it as a columnar relational table, I want those columns to have very quick access so I can do calculations on them. And doing so, I may actually have a structure of those nodes, in effect, those nodes being next to each other or near each other in memory, or at least quickly accessible, for example, in a cache or even in random access memory. So they're quickly accessible from each other. And if I do that and I say, okay, that's great, but then I want to put this in a binary tree for fast access, well, then my binary tree is going to, still require some nodes to be fairly far apart. Now, why I might put in a binary tree? Well, it's a binary tree is very fast to find things and very accessible. In fact, another result of DEL is if we have a graph or a grid that's of some power of 2, then that grid is embeddable into a binary tree with a bound of 8, which is actually very nice, a particular binary tree. So they actually say, hey, we can even embed them pretty darn well in binary trees if we have a power of 2 and then we have a fully balanced binary tree in this case. So if we don't have a power of 2, we don't have quite as much luck because we may have an imbalanced tree that throws things off. And this reminds me of how, in fact, we built, or not we, but our predecessors in computer science built relational databases using B star and B trees. So here is an example of a B tree that is actually, now if you're not familiar with it, it's kind of fun to take a peek at this. B trees usually are very shallow. They're maybe 2 or 3 levels down. So here I have one level at the top, and at the top here we have 102, 438, etc., and all the way up to 9,384. That is a those are values that are in the rows. So 102, that first 102 says all numbers that are less than 102 in the number column. We have 1, 12, 31, all the way to 101. Those are all less than 102. So the levels below this that points to that first down arrow, they refer to all things, all rows whose numbers are less than 102. And we can see that we can isolate each of these different rows in a similar pattern in this B tree. So this B tree has both sort of a logarithmic depth, though not quite, it's really kind of a fixed depth, but it also happens to have a binary searchable property at each level. So that first 102, 438, etc. is ordered increasingly so we can actually go to different chunks or different rows in the table. And so the B tree is a way of saying, hey, we're going to kind of have a balanced binary tree here, and we're going to even do better than that. We're going to make our chunks of these rectangles of numbers so they fit well in the cache. So we can actually, if we keep repeatedly hitting them, we'll be able to handle them well. So the B tree is a real example to me of the result of graph embeddings actually being helped out by careful architecting of the sizes of these different data structures and the way they're implemented. And so that's really good. We're kind of chasing the results of graph embedding by Lipton, Eisenstadt, and DeMillo. And so if we were, that gives us a better situation to look at graph databases, because if we have to have relational databases, we can resort to being lucky with balanced binary trees or maybe even B trees that are carefully architected for our systems. On the other hand, why not just build the graph to describe the actual data to begin with? Okay, then we're not going to have to worry about this logarithmic factor in terms of representation, or if we're lucky and we get a truly balanced tree and a power of 2 for our number of nodes. There's a power of 2, then we can maybe have a factor of 8 there or something like that. But even that is a little bit costly. Let's just have the graph structure as we are. And so this takes us to the next step, knowledge graph embeddings. And then we're going to take this and we're going to cycle back around and talk about these naming authorities again. So for example, knowledge graph embeddings is a nice survey by Wang Mao, Wang and Guo on knowledge graph embedding. But one example of this, they often do this in triples. So they have a header, a relationship, and a tail element. So for example, Feynman teaches physics. Okay, so this is a relationship between entities. Richard Feynman and the subject of physics, and teaching joins those two. We could also say something about one of our entities. Feynman has feelings such that he doesn't worry about what other people think, which is a famous book he wrote. Okay, and then of course facts and distance metrics can be used, and we can classify nodes and do link prediction, and that's what I want to get back to in a few moments here. So one thing we can do is we can validate our knowledge graph. And so sometimes with art of famous artists, we really know a lot about them, but famous artists are fairly rare in terms of the whole pool of artists, although they're well known, of course, and all these other good things. So what we're interested in is, in this bottom line here, is validating these relationships and perhaps getting a correctness score. We're not that interested in transitivity. So in dealing with the type of data we're looking at here, A has a relation to B, and B has a relation to C, then A having a relationship to C as well may not be that interesting to us. So I'm not gonna, it could be, but not usually. So here I'll look at what I think is a great artist from India, actually, Ravi Varma. And I took his ISN number, which is right here, and I just took a teeny snippet of all the different equivalents for Varma's name and numerous other languages and scripts, who are all very beautiful themselves. And then I looked at his ULAN number. So here on the right side of the screen, you see his ULAN number. So he's being identified as the ISN number, and that gives us all sorts of different ways he was named in different languages. ULAN is a little different, this data set. ULAN is going to be focused on, let's identify this person. Who is this? So if you look in ULAN and put Ravi Varma, you'll find there's two of them. One is an architect and the other is an artist. It lived at different times and everything else. But if you focus on the artist here, you'll see what they were, their roles, their gender, their birth and death places, other places they may have inhabited, different factors about them, other events in their lives. So we could both have all their aliases and then have things that help identify them, which could give us confidence of who we're talking about in a system. Then we might go to the VOF thing, and the VOF naming authority. And the VOF naming authorities, remember, aggregates a whole bunch of countries' naming authorities, like, for example, museums and libraries that might point to who holds these art pieces or where they are, or even hold them themselves in case of museums and things. And so this has this nice chart, VOF, on the right side, that has a bunch of flags for these different countries, in which case you can click and find out. So, for example, if you click the American flag there, you'll find the Library of Congress has some details about where, are we okay? Where some of his work is. So, like, for example, Lady in the Moonlight, which is a very beautiful piece in my opinion. And we can get some birth dates and death dates, and we can find out when his particular paintings were done and understand that. And this can give us a graph database that looks somewhat like this. This is a little bit simplified, but we might have artist one being born in a particular year. They have different paintings they have produced or different art pieces they produced. Then we have holding companies that may be holding those, or the rights, like the right to hold it, or the museums, or somebody may have their copyrights. And those holding companies and rights holders may contract and absorb each other, or sell off pieces, or sell off components, or be bankrupted, or other things. So those change dynamically in the top level. The art pieces themselves don't really change, although we can worry about provenance, that is forgeries and things like this. And of course, we can validate some of these things based on some data from different entities like ULAN and VOF and ICDMAI. Well, this artist wasn't born then, so he couldn't have produced this piece of art, or this other artist jointly did this, and they're both working at that time in the same city. Okay, it makes some sense. So, for example, ISN or FIGI data can tell us about the entities that control or hold the pieces or the rights to this pieces, or the books, if you're looking at things like that. VOF can tell us about the pieces or details about the holdings and where they might be. ULAN on the bottom level here can tell us, and ISNI can also tell us, ISNI can help disambiguate the name or give it to us in many different ways. And ULAN can tell us all sorts of features and data about the particular artists and how they were there. Okay, so these may give us many interesting embeddings, and also we can augment these with rules. For example, if you're born, or an artist is born in a particular year, then of course they didn't produce any art before the year they're born, and other rules of that nature. If they produced a piece who's locked into copyright of a certain nation, then that piece they must have produced in that nation, so they must have been there. So we can do some simple automated reasoning. And we can get these facts, particularly they're interesting around edge cases. So if you have an edge case, well, this person moved that year from this part of this country to that part of this country. So it's unlikely that they completed it there, but maybe they completed it somewhere else and brought it with them. So we can get some interesting use cases there. Now, one thing when you see a big graph or graphs you might think of is dimension reduction. And so how do you do that? Well, one way I think of dimension reduction is in tables. I think back to relational databases, transactions or financial positions. And we can think about computing eigenvalues from the adjacency matrices in those cases and look at the biggest eigenvectors, which contain the most information. So we can do principal components to reduce dimensions, but that doesn't quite fit here, I don't think, too well. But we can separate these graphs into identity, objects, the rights, holding organizations, and we can use ULAN and ISNI, which have some intersections, so we can in some ways maybe get some dimension reduction there. VOF has many authorities that use it. Sometimes I've seen ULAN records in VOF and things like that. And then there's, of course, holding organizations, FIGI and ISNI. Those, not a whole lot of dimension reduction between those, but there's maybe a little bit. So in conclusion, there's abundant and extensive naming authorities out there, ISNI, VOF, ULAN, FIGI, and others. There's many opportunities, and a lot of these are driven by payments, which is no surprise. Economic force helps get things done and helps give things a continuous life. So ISBN numbers are real important for publishers. Okay, they're going to keep those alive and going. Just like ULAN has been done by and driven by a foundation, the J. Paul Getty Foundation, a very wealthy foundation. And there's many cool things that people are doing and can be done, like ISNI giving us all these different languages, all these different references can give us broad NP and natural language processing, questions. Graph embeddings can be expensive, but we could look at graph embeddings of different artists and see how they fit together or don't. And so, questions?
Excuse me, sir.
Pardon me?
Excuse me, very good morning. I am Dr. Arun Kumar from BMSIT, Bangalore, India.
Yes.
My question is, I listened to your lecture. I could understand the graph database is very much useful since the table itself can be embedded in the graph.
Dr. Ravi, your voice is echoing. If you can put the mic closer and speak.
Yeah, sure. So, is it okay, sir, now?
No, I think it's okay. Try and speak, please.
Can you please explain me why graph database is more useful or more the data science or storing the huge database, sir?
No, again, we lost you. Please speak slow and keep the mic close to yourself. Then only we'll be able to make out what you are speaking. Otherwise it's getting lost in echo.
Hello. Now it is okay, sir?
Yeah, yes.
Okay. Sorry for the network problem. I wanted to know why graph database is preferred in data science compared to the relational database. Is it with respect to the accessibility of the huge data is concerned, or the representation of the huge data is quite easy or less complex in graph database?
It's a great question. So the graph databases sometimes reflect the data science better. So they reflect the way the data is actually organized. So if you have a relational database, you can do anything you want, right? You can do queries, we can do joins, we can do find paths and things like this. But we have to do extra effort. And this kind of goes back to the embedding results of DeMillo, Eisenstadt, and Lipton, is when we have a rectangular structure, sometimes the data is not going to be close. Close data is not going to be, that's close in the columns is necessarily going to be close on, in the structure that represents it, unless it's a true binary tree, then it can be. But it has to be a binary tree with an even power to do it really well. So the idea there is, why not just have the data more faithfully reflect its relationships, as opposed to have to worry about, before I even start working with the data or finding a path with the data or solving a data problem, I have to do some complicated SQL queries. And look, we all like SQL, but I think we're trying to make the graph database more faithfully represents the structures that we have in data science.
Sir, this is Dr. Pradeep. Hello, is it audible?
Yes.
Yeah, I wanted to know from the graph theory, like there is something called DAG, directed acyclic graphs.
Yes.
So how do we interpret that in data science? Will that be helpful in the graph databases, like assessing the cost factor and getting the correlation between data points using a directed acyclic graph?
Absolutely. So cycles in some of these things can of course be indication of a problem. I mean, the type of data I'm working with. So the data for an artist, it'd be unusual to have a cycle in it. So these are directed graphs, because usually the data we have is from a head through a relationship to a tail. So for example, this artist was born in this year, or the lady with the moon was painted or created by Ravi Varma. So these are arrows. So these are directed graphs, and cycles would be unusual. That's usually an indication of a problem. So this is probably your point is very well taken. So I think DAGs are very important here. And
it would have been great if you have an example illustrating that. So exactly, it will depict the cycles and the dependency between the data objects. When there is a cycle occurring between the data points, how do you tackle that? I mean, you need to either do something on the proximity.
That's
I think
right.
I'm just interfering. My suggestion is you take it offline, because it's
sure.
more on subject.
Okay, fine.
So please.
You
over
please
to
email me and we can chat about it.
Sure.
Or I'll be around for a few more hours anyway, so I'll be in one of the rooms.
Sure.
We have a discussion.
Inder sir, do you have time for another question?
Actually, we are running short of time, but if it is a very quick one, I think can do it, but we're running short of time. So one last question, please.
Okay, okay. Brett, this is Saptarshi here, and uh, from a data science perspective, so how do you decide when still we cannot really do away with the relational databases, right? So there will be a lot of things in the relational database, and we can understand that graph can really give semantics and relationships much better insights, and resolve ambiguities much better. So how these two interplay when in a problem I need to not get data from both of them?
Yes, no, excellent question. So we absolutely do we use both. And so way I view it is relational databases are artifacts of transactions. Okay, so for example, this art was purchased on this date. Now this art may have many columns. It may have a purchase price, a sales tax. It may have a owner, new owner, old owner. But those are transactions. Then what I'm interested in doing is I'm interested in reasoning about those transactions on aggregate, in which case I build a graph database to describe the flow. So this artist, he painted all these things. He died here. He had a child there. He had a partner over here. So, but each of those pieces of art will be in the relational database. Does that make some sense?
Yes, yes, of course, of course. Thanks a lot. Thanks a lot.
Thank you.
It was a great talk, Philip.
Professor Philip, it was really very interesting and very informative session, and lots of takeaways from your session. And there are so many questions. I think we'll take that offline while you're here. And people have learned a lot during your Power Pack session. Thanks for your address, and as a token of appreciation, please accept from our side. And we look forward that you will be here for some more time with us. And thanks for being up late at night for being on the ICDMI 2021. Thank you very much, Dr. Phillips.
Thank you. Thank you. That's very nice. Thank you for this nice certificate.
Thanks. Thank you.
Thank you.
And now we move ahead with Saurabh Mukherjee. And Saurabh Mukherjee is the Vice President, Data and AI Group at Accenture. And a couple of words about Saurabh Mukherjee. He's more than 24 years experience in IT. He presently works as VP in Data and AI Group in Accenture. Prior to this, Saurabh was an associate partner with IBM, leading IBM's analytics practice, and an associate director with Cognizant Technology Solution. So I heartily welcome Saurabh Mukherjee for giving a keynote address on AI.
Well, thank you. Thanks for that wonderful introduction. Very good morning, afternoon, evening, depending on where you are. I would definitely like to thank ICDMAI for this wonderful opportunity to present a topic which is very close to me. Give me a second while I share my screen. Yeah, is my screen visible?
Yes, we can see that.
Okay, thank you very much. So I think this is a topic which is extremely close to my heart, and as a philosophy, I think this is something which is a key consideration for a lot of organizations, for a lot of industries, and for humanity in general. That's the way I look at it. So very interestingly, what I call this as the dilemma of the post digital generation. That's primarily us. is that on the one hand, technology obviously has become a pervasive part of the human experience, right? So we are progressively increasing our usage and our dependence on technology for everything in our lives, right? And if you really look at statistics today, uh, more than half the world's population now has access to the internet, and mobile devices have become cheaper. Network access has become more easily available, and around the world, people are constantly connected on every type of device. And if you look at the statistic, it's that an average of more than 6 hours are spent online every day by the average urban human being. Now, which is all fine, but on the other hand, uh, there is a contradiction. So on the other hand, what's happening is people are also experiencing what we call a tech lash. So that's the term which is gaining popularity significantly, and it's called tech lash. What it essentially means is a backlash against technology, right? And it may sound uh, very contradictory to the human behavior that we see around us today, but you see it in the fact that people are putting a lot of emphasis on digital detoxing, for example. There's a lot of importance on how do you reduce the screen time, how much time that you spend looking at a screen. It could be your mobile phone, it could be your tablet, it could be a PC, but there is a growing uh, tendency to reduce that time. And you would see that a lot of governments and organizations are also bringing about regulations on technology, right? So there are devices today where you can actually turn the device off after a certain time. And so we have the dark mode, for example, that has now been introduced in a lot of devices, more as a sort of a precautionary measure for your health, and a lot of other reasons. So there is a bit of an inconsistency that we observe, right? And I think that sort of brings us to this very interesting topic, because it is no longer about human beings on the one hand, and technology or artificial intelligence or intelligent devices being on the other side of the fence. But I think the key message here is about human and AI collaboration. And what I essentially mean by that is the need to take a new approach that uses artificial intelligence to bring out the full potential and the full power of people in the post-digital era. I think that is the key uh, objective that we are all working towards. That how do you utilize artificial intelligence not as something which is a very different entity or something which is very distinct, but it is more about how it can bring out our true potential. And what I will talk about today is how do you actually go about doing that? How do you make this very pervasive and very immersive, and not a very separate entity that you talk about? So the whole idea is that if you look around today, whether it's a commercial organization, whether it's in education, whether it's in healthcare, uh, mostly what we observe is that AI, or artificial intelligence, is primarily being used for automation. Now we really need to move away from that. So AI is not just about automation. What we essentially need to do is to get into a new frontier of co-creation between people and machines, because that is the future of not just the workforce, but that's the future for the world. And this trend really highlights a new collaborative model for people and AI, as I said, not just in the workplace, but in all areas of life in general. And it sort of describes what businesses can do to reimagine the role of artificial intelligence in an organization. And I'll also touch upon the different technologies which are gaining a lot of currency because of that. So technologies like natural language processing, or image recognition by devices. And but at the same time, there's a huge dependency on people's ability to steward, direct, and refine some of these capabilities of artificial intelligence. So I think that collaboration is extremely important. Uh, Talking of collaboration, there are two interesting metrics that I wanted to present here. And, these metrics are derived from a lot of surveys that, we've conducted as part of Accenture with a very large number of Fortune clients. So what we see from the survey is a very interesting observation. We see that there are 73% organizations which reported that they are piloting or they are adopting artificial intelligence in one or more of their business units, which is excellent, and I think which is also expected, right? But what is slightly alarming is that only 23%, and that's a really small fraction, right? So only 23% of organizations reported that they're also preparing their workforce for that collaborative, interactive, and explainable artificial intelligence based systems, which means that, like I said earlier, that a large percentage of organizations are essentially using artificial intelligence, probably to automate or to optimize a lot of their processes. But there's a very small percentage of companies which are really aware of the fact that it is not important just to deploy artificial intelligence as a mechanism to automate or optimize their operations, but it's also equally important to prepare their human workforce for this technology development and how to bring about that collaboration between human and machines, which is going to be extremely important in days to come. So uh, let's move on to the next slide, which is more about what exactly is the situation globally in terms of artificial intelligence adoption. And what we realize is that the businesses today are realizing only a fraction of the artificial intelligence potential. So there are a number of leading organizations which are just plugging artificial intelligence and other technology tools into their existing workflows, into their existing business processes. And the focus is primarily on automation and optimized execution. But simply using artificial intelligence to make the organization run faster or cheaper is actually limiting its true potential. And that is something that all of us must understand. To summarize the business problem, essentially what's happening today is that you have your traditional workflows, you have your traditional business processes, which had a lot of human dependency. What a lot of us are trying to do is leverage the capability of artificial intelligence, and we are simply trying to make those processes faster and more optimized. But that essentially limits the power of artificial intelligence. So where do we go from here? So ideally, the need is to find use cases or to find true business scenarios where artificial intelligence and the human workforce can actually collaborate. And in order to be able to do that, businesses will need to explore and master the tools and advancements so that machines and human beings can better engage with each other. And as we go along, I'll talk about some of those technology capabilities that we essentially need to look at. But at a high level, uh, there are a few technology trends that people and organizations must pick up. And some of these are natural language processing, extended reality, explainable AI. And as I go along, I'll touch upon how broadly, these three key technologies can actually bring about that kind of human and AI collaboration. And this will actually unlock new ways and techniques for people to interact better with machines, creating a more effective workforce, which is a collaboration between human beings and machines. Now, so what will then happen is, this collaboration will open up new frontiers for the enterprise, and the companies will need to engineer ways for human employees to couple their unique talents and knowledge with the limitless capacity of machines to explore these new frontiers. Now, those that do so successfully, those organizations and those institutions that can create that collaboration and coexistence successfully, they are the ones who will build the new generation of intelligent business. They are the ones who will create the new generation or the new society that we look forward to, where humans and artificial intelligence systems will work together to reimagine possibilities that we probably cannot even think of today. Now, So the key thing is, so this is all very fine, right? So this is an excellent philosophy that I think we all agree that it's technology is not separate from people. It is not something which is which is a black box for you, but it has to be immersive. It has to be collaborative. But what is the first thing that we need to do? What is the first barrier that we need to break uh, in order to get there? So context is extremely important. Context really matters. And to put it very simply, to successfully collaborate, humans and machines need to understand one another more effectively. And what I personally believe is that in a lot of the artificial intelligence applications that we see around us today, be it commercial organizations, be it academics, be it healthcare and other essential services, I think this is one area where there is a tremendous scope of improvement. Are human beings and machines really getting to understand each other better? And enabling that collaboration, it has to start with mastering the tools and the advancements that can really help humans and machines better understand and engage with each other. So like I said, let's look at some of these technologies and tools that can really help us get there, right? So the first thing is, so let's look at this whole collaboration mechanism from the perspective of the machine, right? And that is where two technologies where we are focusing on at the moment. One is obviously natural language processing, right? So that is extremely important for the machine to understand the human being, right? And I think there are, if you look at the one of the key focus areas for artificial intelligence today, it is conversational AI, right? And there are multiple reasons why conversational AI is becoming extremely important. So first of all, as human beings, we communicate more freely, we communicate more effectively when we talk, as opposed to let's say a textual communication, right? And I think we experience it every day. If there is something really important, if there is something where I need to explain myself to a fair degree, I would probably pick up the phone and talk to another human being rather than trying to send him an email or a text message, right? So that's a pretty relatable point. Now extend the same concept to a machine. When you want to talk to a machine, rather than giving out a set of commands in a textual manner, you can communicate more freely when you are dealing with a conversational artificial intelligence system. The other very important advantage of using conversational AI is that it results in faster adoption. So tomorrow, if you were to interact with a machine and I gave you a very complicated user interface, and I tell you that this is the only interface with which you can communicate with this particular machine, there is obviously a lead time for you to get comfortable with that interface, to understand how to use that interface, and then communicate effectively with the machine. Whereas if the interface is based on conversation, you can probably start using it very fast. And also think of human beings from previous generations, who obviously have um, the lead time for them, who are probably not as comfortable with emerging technologies as this generation is. For them, probably it's a significantly longer lead time. So again, for them, conversational AI sorts out that part of the problem much quicker. uh, the third and very important aspect of using conversational AI, again, is think of all of these applications in factories, or let's say in laboratories, right, where people are conducting uh, research and development kind of activities, and there is a potential to automate a lot of these artificial intelligence interfaces. Now what we see in a lot of these places, and it's a very practical problem, is that people would probably wear gloves, right? And for a variety of reasons, it could be the reasons, it could be environmental reasons, it could be security reasons, health reasons, whatever. But so yeah, in such scenarios, when you actually have to wear protective gear, and you may not be in the right status to probably use certain kinds of device interfaces, again conversational AI becomes extremely important. You are just talking to somebody, just like you are talking to a colleague, you are doing the same to a machine. So conversational AI, is gaining a lot of credence. Now, the second very important aspect from a machine's perspective, once again, is obviously uh, extended reality, right? And I think just so that for those who are not very familiar with the term, I'll just take a couple of minutes to briefly talk about that. So extended reality, or XR as we call it, it encompasses different kinds of virtualization. So you have the simplest form is augmented reality, or AR as we call it. So in augmented reality, what happens is I, as a human being, am not detached from my surroundings. So I still know where I am. I still know what's going on around me. I still know who are the people in front of me. But I am just, but augmented reality, or AR, just augments that real scenario and adds digitized text or images, or digitized content on top of my actual reality. So I think the simplest example is that a lot of us today use filters on our mobile phone applications, and you could just take a picture of yourself, and then the app allows you to put maybe a cap, or a pair of horns around your head, which sort of, and you create the digital picture that way. So this is the simplest example of augmented reality, right, where you are not detached from your surroundings, but there is additional digitization that's happening on your on yourself. Now, the next level of sophistication, of course, is virtual reality, or VR, where in contrast with augmented reality, what's happening is you are completely detached from your surroundings, and you are probably finding yourself in a battlefield, or probably you are finding yourself walking on the moon, but the bottom line is that you are completely detached from your actual surroundings, and you are in a simulated digital kind of an environment. And virtual reality, of course, has a lot of important applications, especially in training purposes, where you are in hazardous training. So for example, in military training, or think of a COVID situation where we are today, where you are training a lot of healthcare professionals without actually putting them at the risk of walking into the COVID section of a healthcare facility. So there are a lot of possibilities and a lot of applications of virtual reality, for example. And but the most exciting thing that's happening in this space today is what we call hybrid reality. And hybrid reality is basically a combination of your actual reality and the virtual reality that we just talked about. So in hybrid reality, what happens is you are aware of your surroundings, you are aware of where you are, and who you are communicating with, and so on. But then you can bring in virtual components into that reality. And two extremely important, two very popular applications that we are seeing today is where Rolex has actually launched an app where you can select a particular watch, and you can actually bring it using the whole mixed reality, or hybrid reality as we call it. You can actually try it out on your own hands virtually and see how the watch looks on you. IKEA is also doing something very similar. So IKEA now has an app where you can actually select a particular piece of furniture and see how it looks in your living room, the actual living room where you are at this point in time. So it's very important, because what's happening with extended reality, so which sort of covers all of these different, so XR, which covers all of these different kinds of augmented, virtual, and hybrid reality, is a way for the machine to understand you better, right? And in fact, a lot of you may be aware of this device called the HoloLens. So HoloLens is basically, the whole virtual reality gear that was manufactured by Microsoft, and the new version of that lens has now come up, HoloLens 2, and the most interesting part of HoloLens 2, which in my view is actually taking this whole human AI collaboration to the next level, is the fact that HoloLens 2 not only recognizes your surroundings, but it can also interpret your surroundings. And like I said earlier, it's very important for the machine to understand the human being, and HoloLens 2 is a step in that direction. So to give you a simple example, if I am sitting on a couch right now, the machine through this whole image recognition process, can not only figure out that there is something behind me, but it actually knows that yes, it's a couch. It is something that a human being sits on, and the couch is probably in my living room, right? So I think that understanding of the human context by the machine is extremely important. So I think we talked about natural language processing. We talked about augmented, virtual, and hybrid reality, which is the way of the machine to understand us better. Now, for the other way around, right? I think for us to understand the machine better, I think this is where explainable AI is becoming extremely, extremely important, and for various reasons. So, see, first of all, what's happening is I think traditionally, till some time back, AI has almost been considered as a black box, right? So somebody has built in some intelligent algorithms. You are providing the right inputs to the models, and it does some magic inside that black box and gives out the outcome that you are looking for. Now, there are obviously a few problems with this kind of a model, and this is what more and more organizations and institutions are slowly realizing. There are quite a few problems with that. So, firstly, in this kind of a model, when you have the modeling or the whole artificial intelligence processing happening inside a black box, if you will, uh, then if there are inherent biases in the model or the way you have designed the whole system, uh, there is no way for you to correct those biases because you don't even understand what exactly is going on inside the black box. The second very important impact that we've seen, and there were quite a few interesting goof ups, if I may say, that happened, is because of the data set that you are using to train that particular model. And if there is something inherently wrong with that data set, in terms of its accuracy, in terms of its quality, then obviously the outcome that you get from the automated processing is not going to be correct. So if you get a view of how the whole artificial intelligence algorithm is working, then there is an opportunity for you to fix that bias. There is an opportunity for you to fix that data quality problem, which may be causing that impact. So that is one benefit of making AI explainable to the human being. The second very important reason why explainable AI is also becoming important is because of a lot of regulatory and federal requirements, compliance requirements, right? So it is not soft. So if you are in an extremely critical industry like finance or healthcare, then it's not enough for you to say that you know what, I have deployed this very expensive artificial intelligence solution in my organization, and this is how this particular process has worked, and I have no visibility to what is going on. You cannot say that to a federal authority. You cannot say that to a regulatory body, right? So obviously you need to have a very thorough understanding of how that particular process works, how that particular system works. So again, it is very important to have explainable AI. And lastly, again, from the perspective of the human understanding of how the machine works, is because and I'll give that example, a practical example, a couple of minutes later, is that in a lot of cases, you are answerable to your customers, right? So as a business, you are answerable to your customers. So it is very important again for you, for example, when you are claims processing, in an insurance industry, or when as a financial institution like a bank, you are issuing a loan, and let's say the loan application of a particular customer is rejected, and you have the whole process automated using an artificial intelligence platform. Now, if the customer tomorrow comes to you and asks you, okay, why did my loan get rejected? What can I do in order to make sure that my loan application is approved? You cannot say that, hey, it's the machine who has taken that decision and I don't have a clue as to what happened. So you definitely need to understand what exactly was happening behind the scenes. So this is the other part of the equation, right? So this is where a human being needs to understand the machine better. So to summarize, we talked about how these two parties can get to know each other better. The machine probably has to understand the human beings through technologies like extended reality, natural language processing, whereas the human beings will have to focus a lot on things like explainable artificial intelligence in order to understand the machines better. So So what's the price? So if I make the investments, in terms of setting up these kinds of collaborative technologies, what happens is that the enterprises that very successfully uh, create this ecosystem of collaboration will be able to reimagine their organizations from the ground up. So it is not just plugging in AI in certain places within the company just to optimize and accelerate, but you are reimagining the very way in which you conduct business, or depending on your the industry that you are in, you have to redefine a lot of these processes from the ground up as to how you can make your human workforce and your artificial intelligence to work in collaboration. And the human AI collaboration has the tremendous potential to completely transform the way businesses are structured, the way you design products, for example. And I'll talk about how Volkswagen is doing this very shortly, I think in the next slide, as to how do you do product design, not by automating the process, but by actually sitting with artificial intelligence, but by sitting next to a machine and working together, putting your brains together and coming up with something exciting. How you hire and train your employees, right? How you use artificial intelligence in training. We talked about virtual reality, the application of virtual reality in that process. And the true pioneers of the industry are the ones who will use these capabilities of human AI collaboration to reinvent themselves, and they'll handle bigger challenges, and they will drive the next generation of intelligent business. So that's what you get out of this. I'll very quickly touch upon two very interesting case studies, which I personally found very exciting. Is the whole collaboration between Volkswagen and Autodesk. And so when I say a Volkswagen vehicle, what comes to mind? It's an iconic vehicle, right? And so if you want to really update it, right, and if you really want to add some of the benefits and expectations that we have today from a modern vehicle, in what ways can you really upgrade your own historic design? In fact, that's the challenge that Volkswagen had in front of them. The design which has been there from the 60s, probably. How do you sort of upgrade that and make it more more contemporary and modern? So what happens is, as the designer in the process, so think of somebody who's the designer responsible for doing this. So they wanted to partner with Autodesk and bring about an artificial intelligence in the whole process of design. And as the process continued, what Volkswagen did was they, in contrast with the traditional way of using AI, where probably somebody would already have a blueprint ready, somebody would already have the kind of raw materials that would be needed ready, and they would just fit it into a system and just move on to production. Instead of doing that, they brought the whole thing up front. So this whole collaboration started right at the exploration stage, right from the design stage, where they sat down with the machines and said, look, these are the features that we want to incorporate into our traditional design. These are the kind of raw materials that we want to use. These are the kind of constraints that I have on the raw materials, in terms of how light or how heavy they are, how fast that would make the car. And then the machine started throwing up a lot of ideas. Some of those ideas were impossible, and they were immediately rejected. But that dialogue continued, right on the design table. So by the time this whole design went into production, this was already a collaborative design which had gone through multiple iterations, and a true example of human and artificial intelligence collaboration. The other very exciting story that I wanted to share with you is about TD Bank, which is a bank in Canada. And TD Bank has recently introduced a tool which, like I said, explains the reasons behind the decisions which are taken by their artificial intelligence platform to approve or deny the loan applications which are made by their customers. So let's say you are a loan officer who's responsible for processing the loan applications, and previously this entire process would be manual. So you would definitely look at the credentials of the person who has applied for a loan, and you would make those decisions manually. But the good thing was, so this was effort intensive, but the good thing was you were completely in charge of the decision that you have made. You know everything about why you decided in a certain way. Now, TD Bank went ahead and made a very large investment in incorporating artificial intelligence across all its workflows, like a lot of these companies are doing. So the primary idea was just to optimize and reduce manual intervention in the whole process. Now, but the problem was that as these algorithms, started taking more responsibility within the business, the explainability became a bit suspect, right? Because a lot of these things were being done by machines. So they put in place, a process of explainable AI or explainable artificial intelligence, which helps build the trust with the employees who are now partnering with these artificial intelligence decision support systems. So tomorrow, if a loan is rejected and a customer comes to you asking for the reason, you can definitely leverage your explainable AI platform and have a complete view, and that view could be in the form of a graph, or it could be in the form of text, where you definitely have information about the processing logic that's being followed by the AI platform. So that's another classic example. So I will end by putting up 3 questions. And I think these 3 questions are very important to understand, because when we talk about human AI collaboration, whether it's in academics, whether it's in industry, whether it's in the area of essential services, when you are designing that platform, I think answering these 3 questions become extremely important. The first question is, are you thinking collaboratively? If you are just putting in AI in certain areas within your operations just to reduce the time, just to make your operations cheaper, then you are not thinking collaboratively. Because for you, in AI, in that case, is just a tool or an agent by which you are optimizing your operations. You are not thinking of how you can co-create or co-produce or co-design. So determine the role that you see artificial intelligence playing in your business alongside your existing human workforce. Don't restrict your thinking only to, okay, these are the tasks which human beings were performing till yesterday, and from tomorrow I'll let a machine do this. No, think in lines of how the same task can be conducted by humans and machines sitting next to each other. So that's the true spirit of collaboration that you have to bring in. The second very important question is that as you adopt artificial intelligence, how do you actually roll these collaborative AI initiatives across your enterprise? Just think of where the industry in general is headed, and this is where some of these areas that I talked about earlier, which is about taking accountability for decisions, being answerable to regulatory authorities, being answerable to federal authorities, in order to ensure transparency about all of these processes that are going on inside the organization. Think through all of these different aspects, and you have to gather your workforce perspectives into the design and implementation of your AI systems. And lastly, is this extremely important consideration of making AI explainable. And I think this is where the true value of human AI collaboration lies, that the machine is no longer just a black box or just a robot, but it's more about how the machine can explain to you its actions and the decisions and why it is acting in the way it is acting. So I think these are extremely important questions that you definitely need to address when you build that collaboration. With this, I would like to end my session, and I would be very happy to take any questions that you might have. Thank you.
So one point, how will you address the fairness in AI? I mean, you told about that, and eliminating bias in the algorithm. Normally, this is one of the
I'll request you kindly first give your name and where are you from, and then.
Yeah, I'm Dr. Pradeep from Bitspilani. Right. So exactly, actually, from your decisions about fairness, how do you incorporate in the decisions? In explainable AI, how do you bring in fairness, and how do you eliminate the bias factor in the algorithms like that?
Right. I think yes, absolutely. I think that's a wonderful question. And so see, first of all, when you talk of explainable AI, So the role of explainable, so I'll break your question into two parts. So the role of explainable AI is just to make sure that AI for you is not just an opaque black box, and there is a fair amount of transparency into what's going on within that particular artificial intelligence platform, and that those details are communicated to you in a certain way. And it could be, it could be through a graph which sort of lays out the whole process. It could be in a textual documentation. So the scope of explainable AI ends there. So it just tells you that, look, this is the data set that I've used. This is the algorithm that has been followed in order to arrive at a certain decision. And this is where the scope of explainable AI ends. Now, once you have access to the data set that has been used to train that model, or once you know what was the algorithm that was created in order to execute that particular process, that is the layer where you have to take the remedial action. And I'll share a very practical experience with you, because you asked that question. A few years back, a couple of years back, in fact, so there was an artificial intelligence platform that was deployed by a company that runs a beauty pageant in the United States of America, because they wanted to automate the whole process of screening of some of the applicants for the beauty pageant. And when the results came out and the results were published, there was a lot of public furor, because of the fact that what was evident from the results was that the applicants of a certain skin color were severely marginalized and rejected. And there was a very large percentage of applicants of a particular skin color, and all other colors had been rejected. And obviously, just a classic example of what I said, the organization was obviously held responsible, and there were a lot of allegations of racial profiling and racial discrimination against them. But come to think of it, poor fellas, they were only going by what the machine had decided for them. But like I said, you cannot in that kind of a situation go out and say, look, I don't know, the machine did all of that, right? So you have to take accountability. And what was found out, when they did an analysis of the data set that was used to run that AI platform, was that the data set itself, which was used to train the machine learning models, the data set itself was biased. So the data set itself had certain definitions of, quote unquote beauty, which was not right. So there was a bias in the data set itself. So then, to your question, so there is a need to fix that data set. And obviously, there are a lot of techniques by which you can do that. In the market today, there are a lot of what we call the question of data veracity. So it is not just data quality, because data quality is more technical in nature, right? So data quality would typically talk about whether the data is complete, whether it's accurate, whether it's timely, and some of those conventional definitions of data. But nevertheless, these are all technical definitions of data. But data veracity takes it to the next level, where you are looking at things like provenance. You are looking at bias in the data. You are looking whether the data is skewed in a certain way. And this is where, you bring in a lot of these data veracity toolkits in order to address the biases and the provenance issues that lie with the data. But as I said, you will be aware of all of these bias issues, or these provenance issues, or the issues with the data lineage, if and only if the AI is explainable to you, and you have access to the data set and the techniques that are being followed by the platform in the first place. So that's how you address, the kind of situation that you talked about, sir.
Thank you, sir. Thank you, sir.
Yeah.
Sir, good morning, sir. This is Dr. Arun Kumar from BMS IT Bangalore.
Hi, Dr. Arun.
Sir, I personally thank you and congratulate you on your excellent talk. It has given very good insight about artificial intelligence. Especially, I am impressed by the collaborative AI and explainable AI, which is very, very important, as you said.
Right.
And I want to know how the virtual reality and augmented reality can further benefit the digital marketing while using AI, sir.
Okay, I think that's a fantastic question. So I think two parts to it, right? So as I said, I mean, when I answer also these questions, I typically look at it from both the human as well as the machine perspective, and I think we have to start thinking in that kind of a collaborative manner in everything that we do. So I think from the human perspective, as I said. In terms of digital marketing, what we are seeing today is that a lot of the retail giants, a lot of these manufacturing companies are extensively using virtual reality. I gave you the example of
Yes,
Rolex,
yes.
which has an app where you can actually try on watches by yourself. And there are in the realty space, for example, and it's a very interesting use case I was reading somewhere the other day, that because of this COVID situation, obviously our mobility has got restricted. Now let's say you
Yes.
want to buy property somewhere. In many cases it might not be possible for you to physically be there and check out the property. So a
Yes.
fantastic application that has now come up in a lot of countries is where you are still at home, but then you are using a virtual reality application where you can actually walk around in the apartment that you are trying to purchase, and you can decide for yourself whether this is good for you. So from the human perspective, yes, I think the benefits are very easy to understand of virtual reality. Now from the machine perspective, like I said, that the machine obviously has to understand your context, right? So the machine has to understand where you are, what exactly you are doing, and that is where because the industry is now realizing that it is not enough for the human being to be virtually present somewhere, but the machine also needs to understand where you are right now. So maybe right now you are sitting in maybe in your living room in front of a computer, and you are sitting on a chair, you have a headset on. So when the machine sees your picture on the camera, the machine also needs to interpret and understand your current situation and context. I think that's where I talked about the Microsoft HoloLens 2 is extremely
Yes.
important, is now they have built in that capability that when it sees something in your background, the machine can actually figure out whether it's a wall, or is it a chair, or it sees something on your head. So the machine, so what used to happen till the next to the previous generation of headset gears is that when the machine saw that, it would just know that Saurabh has something on his head. But now the machine can figure out whether it's a cap, whether it's a headphone, or if it's a headphone, is this a something that also has a microphone going with it. So that's how the machine is also beginning to interpret the image. So and all of these obviously is happening through image recognition and the kind of intelligence that you build into that. So to your the answer to your question is yes, extremely important, but it has to happen both ways, where both the human being and the machine are sort of understanding the context. Yeah,
Thank you very much, sir.
most welcome.
Thanks, Saurabh. Very interesting talk. And, you have explained so nicely how AR, AI, and AR, VR, and explainable AI, conversational AI, in a daily life, I think very pertinently put and put in a very simplistic manner, and taking the kind of, taking out from a black box and giving the actual picture of it. Thank you very much for your
Pleasure.
insightful talk. And as a token of appreciation, can I can I have the slide, please, Anandita? Anandita, can you have the slides? So, as a token of appreciation, we heartily thanks for your time, and appreciate taking off your valuable giving your valuable inputs. Hope to see you again. Thanks
Sure. Thank you very
again,
much.
and great day. I hope
Thank
you'll be here with us for part of the session. We'd like to gain more from you while you're present on the platform. And thanks
Sure,
very much.
absolutely.
Yeah, Shoda, we will be also the member of the panel. Okay,
Yes,
please
yes,
remember. Yeah.
Yes, so
yes, I will be there.
you have to be there for that, right?
Sure.
So
Thank you
thanks,
very much.
thanks,
Absolutely
Saurabh.
pleasure.
So
Thank you.
Anandita, I handed it over to you for the next session.
Yeah, thank you very much, Colonel Indrajit. Thank you, Professor Philip Bradford, and thank you, Mr. Saurabh Mukherjee, for your thoughtful sessions. Now, I would request all our delegates and the guests to please go to your respective track rooms for your paper presentations. And the guests, please, you can choose any of the track rooms of your interest. So we will be back to our next keynote session after 1 hour. Thank you, and please join us in respective tracks.
Hello. Hello.
Yes.
Sir, for track 4, we need to join breakout room 4.
So you can join any breakout room. The options are open to you.
No,
Yeah,
no,
you
sir,
have to
for
go to
presenting the
breakout room
paper.
4. Yes, you have to go to room number 4 for track room 4.
Are
Yeah.
you seeing the breakout rooms?
Yeah, yes.
Join through track 4.
Okay. Thank you.
Hello, Professor Nanda. I would like to join as JR in track 3. How do I join? What is the breakout room? Hello. I'd like to join track 3 as a session chair. What are the rules?
I am not able to get the break.
Yeah.
Hello.
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 Yes.
Myself Nivedita. I want to join room number 4. So how I can join it?
You are seeing breakout rooms option on your screen.
No.
No,
actually, that's the same thing with
software
me.
is not updated. What is your name?
Nivedita.
What is shown on the screen?
I can only see the ICDMAI.
What is your name seen on the screen?
Nivedita Wag.
Which track you want to go?
4 track.
Just a second.
So can you also move me to 178?
Just a second. I'm doing.
Yeah.
I have got a similar problem.
Next.
Sir. My name is GS Mani.
Yes.
I want to go to track 3. I'm not able to get the break.
Which track, Mani, sir?
3.
No, I have requested you to join track 3.
And
Sir, I'm Madhu, sir. Please let me in track 4.
Yeah, please let me in track 5.
So Smita, this is Anindita. आप मुझे track 3 में भेज दीजिए, please.
Sir,
one by one, because now Smita.
Yeah, track 2, sir.
Actually, you just see that option on your screen.
It's not there. Sir, it's not there. That's the reason.
The softwares are not updated. What's your name written on the screen? It is Smita is not there.
Yeah,
sir,
could you
can
please
move me to,
send me 215 Nilanjan to track 5.
Please mention your full names.
Nilanjan Sinababu. 215 Nilanjan Sinababu.
Sam 178 Nida Saher, track 2.
Good morning, sir. I'm Dr. Mary Saujanya. Can you put me on track 2, sir? I'm not able to see the breakout rooms.
Yes, I'll do that.
Thank you.
And ma'am, do you have the Google form handy, right?
Yeah, I have the Google form handy with me.
Okay.
215 Nilanjan Sinababu, track 5.
So I'm the presenter of the next session, 178 Nida Saher, track 2, please.
Just 1 minute. I'm not getting the option now.
Who else? Now I have given next. Next, please.
Mary Saujanya need to be put to track 2.
Yes, sir. Track 2.
Track 2. Next. Anybody else wants the track?
Nirmalaya, why are you here?
Sir, my name is 173 Naman, track 2, please.
What is your name?
173 Naman.
Naman. Which track?
Track 2, sir. 2.
Done.
Thank you, sir.
Next. Anybody else?
I see Kranti here. I think Kranti needs to go to track 1.
Sir, PKD Pramanik, room 5.
What's your name?
PKD Pramanik.
Which room? Track 5.
Yes.
Kranti, very good morning.
Who else? Who has joined as a ASER? Professor Manjaya, are you there? Why are you silent? Shobna? Srinath? Anybody wants to join the room?
और उसका ऑन हैंड इन्वेंटरी
Anybody wants to go breakout? Hello? Hello? Dr. Manjaya? Pallab Das?
ये मेरा पैकिंग बॉक्स है
Hello?
इस पे मेरा आइटम मॉडल ग्रुप एनएसआई
Amlan?
नॉन स्टॉक आइटम अगर मैं इसका ये मेरा नॉन इन्वेंटरी वाला आइटम है अभी मैं इस आइटम को परचेज करूंगा
Hello? Hello?
अकाउंट्स पेबल और
Am I audible?
सो जहाँ पे मैं ऑन हैंड इन्वेंट्री देखता हूँ, ऑन हैंड उसमें मुझे वो आइटम ही नहीं दिखाई देगा ड्रॉप डाउन में जो मेरा नॉन स्टॉक आइटम है, क्योंकि ऑन हैंड लिस्ट में सिर्फ वही आइटम मुझे विजिबल होंगे जो मेरे ऑन हैंड हो सकते, बट पैकिंग बॉक्स स्टॉक आ गया। अब एक बार उसका रिलीज
एक्सक्यूज मी सर, हेलो
उसका इन्वेंट्री चेक कर दो। हाँ
सर, कैन यू प्लीज कनेक्ट मी टू द ट्रैक रूम 2?
Yes, please.
Sir, can you please connect me to the track room 2? My
Hello.
name is. Hello, am I audible?
Hello.
Hello. Hello.
What is your name? Is your name?
173
What is your
Naman.
name?
173 Naman.
Hello.
Yes, am I audible? 173 Naman.
Yes, yes. What is your name?
173
What is
Naman.
your name?
Naman.
Track number?
2.
Track?
2.
Track?
Track number 2, sir.
I did that. I gave you. Now you must be seeing the option on your screen. Are you getting the option?
For some reason, sir, it's
Are you
isn't
getting the
visible.
option?
No, sir.
No, I already assigned to you, so it must be showing.
Yeah, sir. Earlier my net was unstable, so I got disconnected. So it's not. Yeah, sir. It's now. Thank you, sir.
Now I showed you. Now you're. Anyone else wants to go to any room, any track? Hello. Pallabda, are you there?
Shobna 139, sir, track 3.
Yeah, I'm there. I'm just checking out my settings. So I
Okay,
believe.
you want to join some track?
No,
3,
right.
sir, 3.
I have some other stuff to do, so I will be ready at.
So why don't you go to that chair room so nobody will disturb you?
But there is no problem. This is going to be the link on for the talk as well, right? Isn't it?
Yes, sir.
The talk is going to take place in this link only, right?
Hello. Shobna already sent you to track 3.
No, what I'm saying is that the next session, the keynote session, is going to take place in this link only, right?
So what I'm going to do, I'm breaking all the rooms and bringing all of them here. So we have created separate rooms for all the activities. So you can sit there so nobody will disturb you, nothing else. So these are the separate rooms.
Okay.
Dr. Manjaya, are you there? Shobna, are you there? Subrata? Subrata? Subrata,
Sheila Rani, you want to go into any room? You please unmute and talk or chat. Subrata, which track you want to go?
Track 4.
Subrata. हेलो हाँ एक सेकंड मुझे ट्रैक 4 में अभी नहीं कर सकता उनको बाहर आना पड़ेगा ट्रैक में कोर्स नहीं हो सकता उनको हाँ मेन स्क्रीन पे अगर वो आएंगे हाँ तो मैं उनको वापस भेजता हूँ ये झगड़ा चालू हो गया फोन पे मेरे को तकलीफ दे रहे हैं वो एक्चुअली नहीं क्या वो इसके बाद फिलिप का मैं स्क्रीन शेयर नहीं कर पाया ये कर नहीं पाया तो फोन पे चालू हो गया इनका नहीं नहीं करना पड़ेगा क्योंकि मुझे बताया यार कोई बड़ी बात नहीं है ना कहीं तो शुरू करना पड़ेगा ना मैं क्या कह रहा हूँ आप पॉजिटिव एटीट्यूड से चलो ना आप क्या कह रहे हो करना तो चाहिए मेरे हिसाब से मैं तो अम्लान को बोल दिया करो बोल क्योंकि कब तक रुकेंगे वो क्या कहना है कि नहीं अपन अगले साल करेंगे अगले साल कैसे होगा फिर वो हर साल आगे जा रहा है ना एंड उसमें मैं क्या कह रहा हूँ इसमें डिबेट कहाँ है इसको नहीं उसको नहीं ये डिबेट नहीं है ना क्वालिटी तो सब में है ना किसी को ये साल देंगे किसी को अगले साल देंगे किए ना मैंने वो बताया उनको तो दैट दे एग्रीड बट अभी डिबेट कहाँ पर है वो रजत मुना को देना चाहिए इसको क्यों अरे इस रजत मुना बट रजत मुना इज नॉट इन डाटा साइंस दैट इज व्हाट आई एम सेइंग ना दैट इज व्हाट आई एम सेइंग और दूसरा ऐसा ठीक है उनको भी देंगे लेकिन उनको अभी इमीडिएट कम्युनिकेशन नहीं होगा तो अगले टाइम कंसिडर करेंगे हाँ तो वो डिबेट कहाँ हो रहा है आप रूल नहीं फॉलो कर रहे बोला रूल कौन नहीं फॉलो कर रहा है सभी रूल फॉलो कर रहे फिर डाउट करने का और डाउट करने का भी ठीक है लेकिन उसके बाद उसको रीजन तो दो कोई स्ट्रॉन्ग रीजन तो होना चाहिए हाँ नहीं क्या नाम है नहीं वो दोनों उधर ही है हाँ Ishita, you want to join any?
Hello. Hello, anyone here? Gojo sir? Hello.
Yes, Dipendo.
Yes, sir. Make me a co-host. I just returned from the
How much
breakout.
time is remain till now? Because we want to close.
Sir, actually, one of the presentators did not appear, and like we just have one more remaining. One is presenting, and one is remaining.
Okay, sure. Thank you.
Hello.
Hello.
How much time, Jagriti?
Sir, 5 minutes I need, sir.
Please do it. Huh?
Max to max 5 minutes, not more than that. Thank you, sir. I'm going back to track 4.
Please. Good afternoon, Pallabda.
Good afternoon. Who's speaking?
Yes, sir. We are starting in 5 minutes, sir.
Okay, no problem.
Yes.
May I know?
Dr. Goje here.
Okay. Good afternoon.
Good afternoon, sir. Neha, can you join Pallabda in session chair room?
Yes, sir.
Hello.
Hello, sir.
So all tracks are over.
Yes, sir. Track 1 is
Yes,
done.
yes. Somehow we had one paper, but I think in the post lunch session we have only couple of papers, so we can add that paper in the post lunch.
So can I bring all of them?
Yes, yes, yes. Sure,
Yes,
sure.
sir.
Track 5 has come. Anybody from track 5?
Dimple, is this possible for you to take a snap of this? And can everyone switch on the video for once so that we can take a good snap?
Yes, of course, I'll do that.
It's so good to see real people.
So we
Yes,
are bringing
actually.
track 5 also back. So within a minute, I am closing the session and we will start our keynote session. Thank you.
Yes, sir. Thank you, sir.
Yes, sir. Okay.
So let's, I think, yeah, you can take the photo, but probably wait for all of them to join back, because I think one of the tracks is still not here.
Yes, yes, we're waiting. I'll
Okay.
start only everyone is there and Koji sir announces.
Yes.
But we can take a good photo.
Yes.
Oh yeah, anytime.
I think Goje sir, he's sharing the screen. That's.
But you can switch on your grid. Yeah.
Yes, 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 yes.
Thank you. Thanks, Dimple.
Okay. Okay, we've done that.
Please do not close the share screen.
Afternoon, Atul.
Hey, good afternoon, Dr. Amlan.
So you will be now the chairing this session. Two very important keynotes, powerful keynotes.
My honor and privilege, sir.
Should I start, sir?
Just a second, I think.
Let us check whether the keynote speakers are there. The Pallabda is there. Let us check.
Yes, yes, we can see him.
Okay, fine.
So I think we can start. Aninda, over to you.
Anindita, sir. Welcome back, everyone, to our main session. We are having two eloquent keynote speakers now along with us. One is Professor Pallab Dasgupta. He is a professor in the Department of Computer Science and Engineering, IIT Kharagpur. And we have Professor Sandeep Shukla, who is a professor at Indian Institute of Technology, Kanpur. This keynote session will be chaired by one of the executive members of Society for Data Science, Mr. Atul Bengare. Atul, over to you, and welcome, sir, Professor Dasgupta and Professor Shukla. Over to you, Atul.
Yeah, thank you, Anindita, and welcome back. Welcome back to the keynote session. And this is day 2 of ICDMAI 2021. And we have a galaxy of speakers with a focus on artificial intelligence. Continuing and extending our foray into this space of listening to the stalwarts on artificial intelligence, we have our keynote speaker now, Professor Pallab Dasgupta, who is presently the professor in Department of Science, Computer Science and Engineering, IIT Kharagpur. He is known for his exemplary work on artificial intelligence and formal methods and their applications on industrial verification problems. So taking academics to the actual use in the industry is what he is good at. He has made fundamental contributions in temporal logic, model checking, and symbolic reasoning. And let's listen to him on his experience and on his insights on the topic that he's going to present to us on this keynote. Over to you, Professor Pallab Dasgupta. You may have to unmute, sir. You're on mute.
Yeah, thank you. Thanks
Yeah.
for the introduction. And let me get started with the presentation. Let me share the screen. Yeah, I hope you can see the presentation.
Yes, sir. We can see the presentation. You can get on to the presentation
Perfect.
mode.
Thank you. Yeah. So between me and the next speaker, Shondeep, we are going to talk about two aspects of AI and ML, which are becoming very important, particularly because AI and ML is becoming so pervasive. That is, in everything that we do, in everything that we use on embedded systems, on big data, everywhere we are having penetration of AI and ML. So safety and security, these are the two real roadblocks in the large-scale deployment of these technologies. So to give you a very high-level overview of what kind of safety we are talking about here, well, when we talk about one of the main problems that, one of the richest test beds of challenges for AI and ML is in autonomous driving, because you have problems of vision, you have problems of autonomous control, you have problems of connectivity with the cloud, and a whole lot of other things. So in this area, if we look at the recent developments, for example, Qualcomm launching its autonomous driving computer, Intel is also looking at various types of platforms which can handle the kind of enhanced computation that is going into the vehicles for supporting driver assist and autonomous driving tasks. On the other hand, there are companies like Mobileye, which has now been acquired by Intel, which focused on the safety and the responsibility sensitive safety. So what we mean by that is that, well, you cannot be 100% safe when you're on the road, because even if you do not do anything which is unsafe, the other vehicles may do things unsafe and you may end up in an accident because of that. So when you talk about responsibility sensitive safety, it means that in the end, when the accident actually happens, your car should not be the one which is blamed. So how do you define that kind of a thing? In terms of safe control, NVIDIA has proposed recently the safety force field, which is a computational framework that keeps vehicles out of harm's way. And if you look at other domains like train control systems, these kind of things have been there for some time now. The problem is that whenever we go into autonomous, as far as safety critical systems are concerned, the confidence that we have from the community is usually not very large. For example, a survey conducted some time back showed that more than 70% of the population are afraid to get into a self-driving car. And there are reasons why that actually happened. If you look at it from the designer's perspective, then to demonstrate with 95% confidence that an autonomous vehicle is, let's say, 20% better than human drivers, you need to test it over 11 billion miles. This is a rough statistics which was computed by a very formidable research team. And based on this kind of an estimate, it becomes very clear that you cannot really do the testing of such vehicles in the same way that you were doing the testing of the other types of embedded safety critical systems, or maybe the standard vehicles that we use today. And in spite of the efforts that are going in there, we do see accidents taking place quite regularly. So in this talk, what I'm going to do is go quickly into some of the main challenges and give you a very high bird's level view of what people are trying to do in order to address safety in machine learning. So the classical supervised learning problem, as you all know, is to start with a training set where you have a set of attributes X for which the values are known, and you also have a set of attributes Y, which is the output of the system. So you have a given set of inputs of the system, a given set of outputs of the system, and you have many different vectors which tells you that for these inputs, what are the outputs. And then the learning algorithm calculates a function, which is a function of a known model, but unknown parameters. And the parameters are learned so that you learn a function h theta, and then you use that to predict the values of y, given the values of x, for inputs which are not necessarily in the training set. Now, classically in machine learning, we are primarily concerned with the accuracy of y. That is, how well does the y predicted by the learned function fit the actual value of y that the complex real world system would predict or would actually evaluate. But this prediction, this accuracy, actually has nothing to do with the safety, because when you're trying to optimize your behavior, for example, for going from one point to another, you are looking at maybe a distance metric or a cost metric. But when you talk about safety, then you have safety as a separate criteria which can impede your movement in certain ways. And so whatever you find is the best way in terms of the optimization criteria may not be the safe way to reach. And then people have actually thought about that, why don't we reflect safety as a part of the cost and just treat it as part of the optimization. The problem there is, in the data, the number of vectors where you have unsafe outcomes is typically very limited. So there is a natural bias in the data, in the sense that the failure data is sparse and the data where you're performing well is quite good. So it has been shown that in spite of a classifier which is very accurate, like for example, the one which is looking at, which is recognizing this signal to be the speed sign to be 20 kilometers per hour. If you add a little bit of noise into it, then it actually reads that as 80 kilometers per hour. So it shows that with a little bit perturbation, though visually for a human being, it still looks like 20 kilometers per hour, the classifier mistakes it as 80 kilometers per hour. And there is a theorem in machine learning which says no free lunch theorem, which tells you that for a given data, when you learn a particular hypothesis, then this hypothesis can be as bad as any other learning algorithm, because I can give you data which is outside your training set in such a way that this one will perform as worse as any other ones. So that means there is no way to define an universally best algorithm for learning. So with that, let us understand what kind of solutions people are thinking of. So one way to look at safety is to reduce our scope of using machine learning methods and confine ourselves to what are called interpretable models. The second option is that I look at the non-interpretable models like deep neural networks, which are very opaque, and as one of the previous speakers pointed out, that they are not explainable. That is, you cannot really make out what is going on inside there. How would you go and verify such black box models? The third direction is, can we constrain the learning in a way that automatically the function that you are learning is safe? And the fourth one, which is something that some of the biggest names in AI are are advocating these days is that we should use a combination of a verifiable or reasoned framework along with machine learning. If you leave everything to machine learning, you end up getting a single black box, which is very difficult to interpret. On the other hand, if you combine reasoning and machine learning, then you get frameworks which are more verifiable, more explainable, and also more interactive, in the sense you can query it and get answers from that. Something that the previous speaker was also enhancing, highlighting and saying that it's very important and required in today's technology. I'm going to look at a set of topics at a very high level in each of these. So I'll not go into any summary description right now. Let's go into the topics straight away. So one classical example of an interpretable model is a decision tree. So to construct a decision tree, you start with a set of data. For example, think of yourself stranded in an island where the only things that you can eat are mushrooms, and you have some journal left back by the previous inhabitants of the island who are no more, indicating which types of mushrooms were found to be edible and which ones were found to be poisonous. Obviously, the ones which were found to be poisonous, the people who consumed them, they wrote the article and then they were no more. So if you think of a data which is given like this, and now you are on that island and you look at a new mushroom, what are you going to do? Are you going to try it out or not? So a decision tree helps you to learn from the data that how do you categorize the edible and non-edible mushrooms? How do you separate them out? So for example, in this, it was found that if you look at all the yellow mushrooms here, well, they were all edible. So that's why the decision tree actually took a statistical decision that if it is a yellow mushroom, then you can go ahead and eat it. And now that is dangerous from a safety perspective, because you may not have data for this kind of a mushroom. So for example, it may so happen that there is a mushroom which has a cap shape of bell, gill color of green, and maybe the cap color of yellow, which is poisonous. Now, because the data did not have any such instance, the decision tree, it learned something different. Now you can see here that there is actually a mushroom which is green and poisonous, but in this direction, because all the pink ones are poisonous, I only looked at the pink attribute and decided poisonous. Color here. So the attributes that you are looking at to examine whether it is poisonous or not is again something that may get hidden or occluded because you did not have the proper data for safety. So how do you get around this? So one way of doing that is to build what is called a default bias. That is, I will make the data biased towards the safety. So in wherever I do not know, or I do not have data, or I do not have statistical reasons to claim that it is non-poisonous, I will not declare it as edible, but I will just be on the safe side and say that, well, it may be poisonous. So I'll keep it under the poisonous category. Only when I have full knowledge, I'll go for the edible. Now, this has obvious problems also, because then you will be very conservative and not be able to take any decision almost always on those which could be edible. And if you don't eat anything, you will die anyway, right? So we have to understand these plays between safety and the ability to take decisions. Another area where, in unsupervised learning, we look upon safety as something which is out of the usual. So for example, if you look at the data here and you do a regression learning here, then you will learn some function like this. And then there is some point out here, which is, which does not fit that function. It is kind of away from that. So we call that as an anomaly, right? And one of the advocates of learning causality, one of the most famous scientists in the AI community, Judy Appel, he has stressed that if you can discover causality from the data, then you can use that to actually make sure that what you are doing and what you are reasoning about is both explainable and in some way safe. So how do you learn such things? So in terms of regression, that's easy. That you find a fitting function and then find the ones which are not fitting into that particular function or have a bigger error. It's more complicated when you're looking at what are called time series data. So for example, in this, suppose we have an assembly line and we have items going in and items coming out. If you look at this data, it is possible to train an engine to learn that whenever something goes in, then it comes out of the assembly after 3 units of time. So which can be expressed in terms of a property like this, that in implies after 3 time units out. And as you can see, that kind of fits this data because I have for each of these after 3 units, it is coming out. It's going in and coming out, right? So that kind of fits this data. So there are no exceptions to this assertion. And therefore, we can have a machine learning algorithm which can find these kinds of assertions from the data. So it finds out the causal relationship and the temporal relationship between in and out. And then once you have that property, then that gives you the basis for pointing out to anomalies. So as you can see here, this one is coming out 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 here, this one comes out here, this one comes out here, this one comes out here, but this one did not come out. So did it get stuck somewhere in the assembly? What happened to that one? So then that is an anomaly and possibly a safety violation. So once you are able to learn as assertions, it makes things very explainable because you can now say that, well, I have seen the pattern that it follows is that everything that goes in comes out of it after 3 units of time. But hey, here is one which is an anomaly because it went in and did not come out. And you can also have temporal anomalies in the sense that here it did come out, but it came out after a long time. It did not come out after 3 units of time, but came out after a pretty much longer time. So this is one direction of work that people are looking at, that we take interpretable models and then try to make them verifiable using various types of constructs. The second area is the verification of black box models. In black box models, one school of methods that people are looking at is called adversarial testing. So the idea is like this, that you have a system S, and then you have a set of parameters P, and you have a set of environment constraints C, and you want to stretch these parameters and find out that under what values of these parameters does the output fail? Do we see a failure in the output? Now, how do you represent failure in the output? So that can be represented in terms of what is called a pass criteria. In the previous example, we saw that the pass criteria was an assertion, but it can also be an optimizable pass criteria. For example, if I have in an adaptive cruise control system where a car is following a lead vehicle, maintaining a safe distance, I may have a requirement that if the distance to the lead vehicle is less than 50 meters, then the relative speed of the vehicle should be less than 40 kilometers per hour. Now, what you can do then is you can actually see the distance between, or the metric distance between the constraint, that is the actual distance that you see here, which is the relative distance, and the safe distance. And the distance and similarly between the relative speed, actual relative speed, and the constraint of 40. And then you can define an optimization criterion using these two differences. And then there are machine learning algorithms like Bayesian optimization, which can find out that what tests you need to give here so that you actually lead to a failure situation. You see, the main problem in handling failure is that statistically they are rare. So unless you push the testing to those regions where the failures will actually take place, you will not see the failures, and therefore your data will always underrepresent failures. And this video actually shows you, let me try to play it, one such example where we are trying to find out whether at what speed, for what kind of vehicle mass, and for what kind of pedestrian speed do you see the accident. So you will see it will repeat the experiment several times until it gets the failure. This time nothing happened. The pedestrian passed through. So you try again. This time you had the failure. So in this way, you do adversarial testing and find out. The other area where people are investigating is whether we can use formal methods to prove that a particular learned system, machine learned system is correct. The problem there is that while we have very good methods for verifying what are called discrete systems, as also systems which have real valued variables, for a deep neural network, the complexity is very large. That is because you have real valued variables which create a very large state space. You have weights which are also real valued and again add to the state space. And you have very complex activation function like say tan hyperbolic, etc., which are not very easy to represent in terms of explorable methods for formal verification. So there are things like Taylor series approximations, etc., which people are trying to do. So let me try to explain the problem of doing formal verification and what people are thinking about it in the context of reinforcement learning. As you know, reinforcement learning is one of the machine learning methods where you try to learn the best way to navigate a terrain and start from an initial state and reach a goal state. The terrain is not known to the agent, which is what we call is model free. So you have to actually explore the state space. The agent has to explore the state space and learn what is called a policy. And the policy will tell that for a given state in your system, which way should you go? So from here, I should go this way. From here, I should go this way. From here, I go this way. From here, I go this way. So that way, you come up with a policy. So a policy in the end is going to give you something like this, that which move do you take when you're in each of these squares. So reinforcement learning is going to find out the set of states through which you go through so that you can reach the goal optimally. And there may or may not be intermediate rewards. And when you reach the goal, obviously, you get rewards. When you talk about safety, that means that there are certain regions which you cannot visit. They are forbidden. And if you go into those, then you will get a huge negative reward. Now, when the state space becomes very large, then this policy is learned into a deep neural network. That is, the neural network tells me that given my state, what action should I take? This one, this one, this one. So whichever one has the maximum activation, that is the one which is chosen. Now, in order to make sure that your reinforcement learned controller does not do anything stupid, there are several things that we can do. First of all, we have to understand that the moment your policy goes into a deep neural network, it becomes non-interpretable. That is, you don't see a picture like this here. The picture that you see here, which shows you the policy, that is not visible anymore because it is actually sitting inside this neural network. So one way to do it is to try to prove the correctness of the network here itself, for which there are a bunch of tools in the area of hybrid system verification, which people are trying to use, but the scalability of the thing is the big question here. On the other hand, we could also do something like take the safety requirements and then modify the reward system, or what is called reward shaping, so that your plant model has the rewards in such a way that the learning will automatically, take safe moves. And the other thing that people regularly use is to use a safety shield. So when you are actually using the controller in the real world, you have the safety layer sitting between the decisions of the controller and the real world plant. So whenever you see that the decision taken by the controller is potentially unsafe, that move is blocked and the safety layer instead replaces it with a safe action. So these are broadly the three different schools of learning that people are attempting to make the machine learning or the reinforcement learning framework safe. I'll not go through these in more details because we are already running late in the schedule. I can share the slides to anyone who is interested. Let me go to the last part. So in this part, as you can see, this is a driving scenario where this vehicle here was trying to overtake the yellow vehicle, and it was actually moving into the region between the two lanes. And now it sees that there is a vehicle coming the other way. So if it keeps on going that way, then there will be an accident. So what does this car need to do? So it basically, as you can, if you have driven a car, you will know that your immediate reaction will be to brake and then come back into this lane, right? You may not be able to come back into this lane straight away because your velocity, this velocity V2, may be greater than the velocity V1 here. So in terms of the driving of a human being, you take this decision first that I'm going to brake and come back to this lane. This decision is a reasoned decision. It has nothing to do with your learning of driving. The second thing is that how do you brake, or in other words, how fast do you brake? How do you actually negotiate this turn to come back here? There, you want it to happen in a rather humane way. So in autonomous driving, people are trying to merge these two things. One is the reasoning framework, where you choose what to do. And the second is how you execute that in terms of a human-like way of braking and turning. The optimal way might be different. It might be that you can turn more aggressively or you can brake more sharply. But the people inside the car will have lesser confidence if you do that. So therefore, it has to mimic the behavior of the human. And that is where machine learning is being used to learn the braking and the maneuvers in a more human-like way. And we are looking at we are building a framework where you can have a program framework, a master program, which is taking the reasoned decisions, and then you have reinforcement learning controllers for different maneuvers like turning or braking or even parking, for example. So these two together gives a more verifiable framework, and we believe that in the future more such frameworks are going to come, where we will have combinations of reasoned frameworks with machine learning. So to conclude, safety is one of the major roadblocks because today certification agencies do not know how to certify black box machine learned models. So this is something which is ongoing. The major concerns in AI safety are that the data from which you turn to learn, they underrepresent unsafe scenarios because accidents are rare. And formal methods face scalability challenges on complex systems. The machine learned model needs to have a capacity which is higher than the function that you want to learn. Otherwise, you will have underfitting problems. But then the verification complexity also grows with that. The third problem is most ML models are opaque, which makes them difficult to verify and even more difficult to explain failures. And the answer, as we believe, lies in combining more and more of reasoning with machine learning And we are likely to see many ways to achieve this in the years to come. Thanks for your attention, and I'll be happy to take questions if time permits.
Yeah, I think we can definitely take a couple of questions. If there are any questions, probably you can put it on the chat or maybe unmute yourself and ask, as long as it's not noisy.
Good afternoon, sir. This is Dr. Arun Kumar from BMS Institute of Technology, Bangalore.
Yes.
Sir, I am very much impressed by your talk on AI and ML. Thanks for your wonderful inputs. And just I want to know how machine learning and AI are actually having some difference, or they are having cooperative contributions of technology towards digital marketing, or with respect to any healthcare sector, for example, in all these sectors, whether they are complementary to each other or they can go differently.
Good question. You know, I was the Dean Sponsored Research of IIT Kharagpur some time back, and I did a survey among my colleagues. And I found out that, you know, more than 80 of the faculty members cutting across departments were using AI ML techniques. Now, what is common between them are the libraries that they use for ML. But the way you use those libraries and the way you formulate your machine learning problem can be widely varied. So the kind of data availability, the kind of techniques that you want to use, for example, in let's say medical imaging, is very different from the kind of one that you want to use in, say, industrial IoT. And when you talk about the comparison between AI and ML, well, AI is the classical AI, or what we call good old-fashioned AI. It consists of the classical techniques of optimization, of planning, of reasoning under uncertainty, etc. And machine learning is the more imitation-based learning framework. So when you want to use classical AI, you will have to create a symbolic representation of the problem. So that may be in terms of a program, it may be in terms of a set of rules, and then you can use those classical algorithms. On the other hand, ML is primarily data-driven. That is, you do not know anything about the physics-based model of the system. You are just given the data, and from that you try to learn everything in a way that imitates the working of the real system.
Thank you very much, sir. Thank you, sir.
To add to that, you know, we are actually using this idea in a very different area where we are collaborating with classical musicians of the country. You know, classical music in our country has been traditionally taught by the imitation way. So the guru actually, you know, sings a few ragas and the student is expected to learn from that. Now, if you ask a student to explain what a particular raga, like say rag Sohini is about, then the person can actually sing it out, but cannot explain why, you know, you call it rag Sohini. Maybe can spell out only a few things like which notes are used, but not much beyond that. So we are trying to see whether you can build a grammatical deeper structure of the raga, which can then help explain, you know, the finer nuances of the raga. So that's a combination of a symbolic way of learning as well as imitation-based learning.
Sir, that means to say that artificial intelligence is more about explanative technique compared to the machine learning.
Yeah, the entire body of optimization comes under the classical AI. So sitting inside your neural network, when you're doing backpropagation learning, for example, is an algorithm called gradient descent, which comes under the classical optimization AI framework, right? Yes. But in terms of the interface or the data on which you're running it, a classical AI will require you to formulate the problem in a symbolic way, whereas in the machine learning community, you would simply go by the data. You learn from the data and try to learn the function or learn ways to do things from there.
Thank you very much, sir. Thank you, sir.
You're welcome.
So I think in the interest of time, probably we will have the questions limited for the time being, and I'm sure Professor Pallab Dasgupta is available in the breakout sessions. You can catch him in one of the rooms. You can even put it on the chat, and we will take it up with him separately.
Sure, thank you, and thanks to all the organizers for inviting me. It was a pleasure.
Sir, thank you so much. The audience is enlightened by your exemplary knowledge in the areas of applying existing statistical models and methods to deduce the safety and security aspects, which you delved very deeply, of deployment of intelligent systems and artificial intelligence. While you covered nuances of machine learning and covering the safety aspects of all that you mentioned, especially on the characteristics of accuracy of prediction and safety of prediction, which is what makes the difference. You covered many verification and optimization models also, wherein you sliced and diced during your talk and demonstrated the usage models which we will be experiencing in the future. So you gave us a sneak peek into the future, sir. And safety needs a default bias is a major takeaway from your keynote. And there is a lot of learning that this would induce people to look at. Thank you so much for your keynote address, Professor Pallab Dasgupta.
Thanks, and you're welcome.
Yes, so we move on to the next keynote speaker. Yeah, just a sec. I think there's some. Okay. So we move to the next keynote speaker, Professor Sandeep Shukla. He's having varied interests. Professor Shukla's teaching interests are formal methods, system level design, hardware, software, and embedded systems. That covers everything. Network application design, formal verification, stochastic methods in embedded systems design, embedded software engineering, and system synthesis. So we welcome you for the keynote, sir, and over to you to address to the audience on the topic of confluence of cybersecurity and machine learning.
Thank you very much. So I'm going to be very brief, given that we are already almost half an hour late. So, I want to talk about the confluence of cybersecurity and machine learning, some of which you are already you have already seen in the previous talk when certain attacks on the machine learning model or machine learning data can take place by adversaries, and therefore compromising the safety of cyber physical systems. But what I want to impress upon the audience is that there are two distinct issues associated with the relationship between machine learning and cybersecurity. So first is what we do quite a bit here in our lab is machine learning for cybersecurity. That is how to use machine learning for cybersecurity. And the second thing is cybersecurity for machine learning. That is how to protect machine learning processes, methods, models, and data from cyber attacks. So these are two distinct issues, but they also have bearings on each other. So machine learning for cybersecurity. So one of the major things that we use machine learning for cybersecurity is malware analysis. So as you all know that all of you use some kind of antivirus software on your systems to ward of virus, trojans, and other kinds of malware. But those are mostly signature-based systems. They actually have analyzed the malware, the companies that produce this software, they have this signature definitions, and these signature definitions are extracted from the malware that they collect using honeypots and other ways. And then this malware is then these signatures are then used to detect the malware on any system. There is also a rule-based mechanism. These are called ERA rules. So whenever a new malware comes to the market, you would see that somebody would produce ERA rules for those malware that you can also use for detecting this malware. The downside of this method is that when you have signatures, you have to already have the malware in your possession. Now, many times what we see is what are called zero-day malware. So zero-day malware are malware that just got released, and it suddenly makes its way to your machines or other kinds of devices. And at that point, the signature definition does not have any rules associated with that malware. And therefore, you have to figure out a way to actually detect those. If you don't have a way to figure out those, then you are going to get attacked. And that's what we saw, for example, in the big ransomware spread that happened in 2017, and WannaCry and NotPetya. These things were zero-day malware, and they spread it very, very fast. And therefore, you need a way to actually detect malware based on behaviors and their features that you can actually learn from other malware and other previous incarnations of similar malware. And that's where machine learning helps a lot. So machine learning on the so you can get a very large repository of malware from various sources, like be it VirusTotal and various other repositories. And then you can actually do two types of things with this malware. First of all, you extract various features from the binary itself, right? So the binary has quite a bit of metadata, as well as if you use various other tools, you will find the strings that are inside the malware that are constant, and they therefore in the binary they can be easily found out. Sometimes the strings are obfuscated, but you can still find out, because usually these obfuscations are in most cases these obfuscations are base64 encoding or other kinds of easy encodings. But sometimes we also get encrypted malware. And when you get encrypted malware, then we can only depend on the metadata that is available for that malware. The second thing that you do is you create a sandbox environment such as Cuckoo, for example, and then you execute the malware. And in such cases, even encrypted malware will unencrypt itself, put itself into the memory, and then execute. There is a little bit catch there. Some malware also are endowed with features that would detect that if it is running on a real machine or it is running on a virtual machine. And usually these sandboxes are virtual machine, and therefore sometimes the malware does not act as it would otherwise. And those kind of malware can also be analyzed by instrumenting your sandbox in a way so that the detecting of virtual machine is not possible, or can be very hard for the malware. So malware usually uses sometimes very simple techniques, such as looking at the configuration of the machine, or memory footprint of the machine, etc., to detect whether it's a virtual machine. In case of Android malware, for example, they also detect sensors, sensor readings, and see if the sensor reading is changing or not. And then accordingly, it will decide that, oh, I am being run on a virtual environment, and therefore it's probably a trap. And therefore they will withdraw from doing what rest of the activities that they are supposed to do. But we have developed sandboxes which are very good at fooling this virtual machine detection features. So in most cases, obfuscated malware or malware that is encrypted can usually end up executing itself in a sandbox environment, provided the sandbox has the sufficient cleverness to remain undetected by the malware. And then you look at the runtime features. So for example, if you have a backdoor, for example, like recently you must have all heard about this SolarWind Orion crisis that's unfolding in the US, or there was this concomitant malware that came. All of them were connecting to, for example, command and control servers back to Amazon Cloud. And those command and control servers were named specifically within the program itself. The names were generated dynamically. This is called the dynamic domain generation. And this we also have machine learning algorithms for detecting when the dynamic domain generation can also be used for legitimate reasons. So it's not always that dynamic domain generation means that it's a malware, but there are machine learning methods by which we can actually predict whether a particular generated domain is actually going to be malicious. So with all these tools, we could actually extract a number of features from the execution of the malware. So we often execute it for several seconds, and then we actually collect, the sandbox is instrumented to collect all kinds of runtime information. We can also take the memory image. So we can also export the memory image from the sandbox, because some malware often bring in payloads which are memory resident and they don't show up in the disk, and various other activities that they do, for example, infecting a DLL file and other things that you can actually detect from the memory image analysis. So now you have two sets of data. One is by analyzing the malware statically, that is without executing it, you find out various features of the malware, and then you find features which are coming from the dynamic analysis. And then together, you can actually have a pretty large feature vector for each malware. Well, we don't know at that point whether it's a malware or benign-ware, so every executable will give you a very large set of features. So next thing is to do feature engineering, and there you require quite ingenuity in terms of first figuring out which features are correlated and therefore can be eliminated, which features are actually not present in many samples and therefore are not probably going to give you a lot of information, and therefore you have to reduce the feature set. And then you do other techniques, other machine learning techniques for feature reduction. It could be principal component analysis or other kinds of analysis to do feature reduction. And then you use those feature set to actually train your models. Now, in case of malware, what happens is that we could do supervised learning in most cases, because most malware that you collect from repositories are pretty well marked by whether it's a malware and also what kind of malware it is. So therefore, in most cases, using supervised learning works pretty well in malware analysis. And most of the time, so we often use AutoML. So AutoML allows you to actually try wide range of models to see which model is the best fit for this malware analysis, your task. That is, you have to give it a goal of what you want to optimize, whether you want to optimize precision, you want to optimize recall, or you want to optimize balanced accuracy. And then you can get the parameter, and you have to give a range of model parameters, and then it will give you pretty much, a near optimal parameter set and the best model. So in most malware analysis cases, we found that the ensemble tree-based models work most of the time the best. So that's kind of how we do machine learning based malware analysis. Sometimes you cannot use machine learning based malware analysis with dynamic features. The reason being, for example, if you want to develop a model for malware detection for Android, in that case, Android is already resource constrained. So if you want to run the malware in a sandbox inside your Android, it's not going to work because it is going to drain your battery and so on. So therefore, what you have to do is that you have to depend on the static features. So you can extract enough features. For example, our analysis shows that we can get up to 99% accuracy in case of Android malware directly from static features. But sometimes dynamic features are required, in which case you have to upload the malware into a cloud and then run the behavioral dynamics on the sandbox on the cloud, and then use those features to detect. But that's going to be very time consuming and network intensive. So that's what we want to avoid. So next thing that we do with machine learning is the intrusion detection task. So one thing about malware analysis is about protection. So as you know that in cybersecurity, we have to do protection, but we cannot rely 100% on protection because protections are breached. And I'll talk about adversarial machine learning in this context to talk about how the machine learning models can be evaded by clever attackers. So therefore, protection can be evaded. Therefore, the next thing that you also have to do along with protection for your system is detection. That is, you have to detect, you have to continuously monitoring and do surveillance on your system, collect data, and then look for signs of breaches and signs of activities that might tell you that something has already gotten into your system. Now, in general, most surveys show that it takes about 280 days from an intrusion to actually detection by most companies. As you can imagine, like in case of the SolarWind case, you saw that that it got detected only after FireEye actually told the world that they have been breached, and the other companies then started looking at it and figured out many of the US government departments, including the Cyber Infrastructure Security Agency, got breached by well, it's not a malware, but it was a supply chain attack, but eventually it's a malware. So therefore, detection, proactive detection is very, very important. Now, how do you do proactive detection? Again, there are certain rule-based things that you can do. Like you can actually have rules for detection of intrusion by looking at the network activities, activities on the host, but that's not enough. So therefore, it is important that you also do, because rules can only detect whatever you encode in the rules. And whatever attack threat models that you have in mind, you encode them in rules. And you also collect rules from which others have done. So there are tools like, for example, Snort and Zeek, etc. For network intrusion detection. You have tools such as WSSEC for host intrusion detection, but they're all rule-based. And if the rules are not enough to catch the activities which are anomalous, then you will be, going to be breached without without you noticing. So therefore, what you have to do is that you have to use again machine learning. And here again, there are two types of situations. One is when attacks show up in the network level, right? So you actually analyze what's happening in the network by capturing packets and then correlating packets and so on. And then there is another that is sometimes there are ways to evade this, and after evasion, it might actually attack your cyber physical system, for example. So the physical dynamics of the system will then start changing. And the goal of the attacker would be to actually move the physical dynamics of the system, of the physical system of the cyber physical system, so that eventually it is laid out of the safe trajectory, that is the safe state space. And they can do not in a very spectacular manner, but they can do this with a very slow change, such that it is not easily detectable and it is kind of hidden in the noise that is usually available, that usually affects the sensor readings and so on. So therefore, you have to be more clever. So in case of intrusion detection, since we are mostly targeting anomaly detection, we found that getting labeled data in this case is very difficult, because there are some labeled data, for example, KDD99 data set for network intrusion, network attack detection, that is labeled because they actually created an environment of a network environment, they induced attacks, and then they collected packets, etc. from those. Even in cyber physical system, we can get labeled data. For example, there is from Singapore, you can get the water treatment plant attack data, which are labeled with 36 different types of attacks. All that is available, but in most cases you won't get labeled data unless you have a pretty good test bed on which you can induce attacks and you can collect data. So therefore, what we found is that for anomaly detection, unsupervised learning works the best. But in order to detect that the attacks are kind of emergent and kind of hidden inside the noise margin of the readings, we have to be more clever. And there we actually have to do quite a bit of techniques for mapping the features from one particular space to a different space. And usually these noises are actually found out to be associated with the lower eigenvalues of the in the original space, and therefore you have to somehow eliminate the lower eigenvalues and create a different different space. So there are techniques such as diffusion map. There are spectral methods by which we actually map the data onto a different space, and then we actually, and in that space, the distance, the distance between distances which are between very different types of behavior and similar behavior, they get very dichotomized. That is, similar behaviors come closer, and dissimilar behaviors get farther from each other in that space. And therefore, you can actually use Euclidean distance to measure distance, and you can then do clustering and other things to actually detect anomalies. And that basically is has been very helpful for us Now, one issue that we also faced is that sometimes the physical system itself changes its behavior over time. Also depends on season, like power systems often behave quite differently in the winter and in the summer. Therefore, we have to also be dynamic in this models and change the model that we learn from the data during summer from from the winter. And for some systems, it could be even more dynamic than just seasonal. So therefore, we have also worked on online learning in this sense that the through the usage of this model in detection, you also add what you detect, in terms of after eliminating the false positives into the model to learn further, so that as the model changes, as the dynamics changes, the model can also slowly drift. If the model changes very drastically, then it's easier. But if the model changes slowly, legitimately slowly, then you need some kind of an online modeling, online learning things. So security incident and event management is an important part of enterprise security. And there again, machine learning is very useful both for intrusion detection and also for other kinds of event detection that may not be intrusion, but maybe user behavior. User behavioral change could indicate, for example, impersonation. Somebody, so you have to build behavioral model of users, you have to build behavioral model of the edge devices, and then you have to use that to detect impersonation attempts and things like that. And then we use this machine learning also in digital forensics and fraud detection. Machine learning has been in use by credit card agencies, etc., for a long time. So you might already know. So I think I have already mentioned this as I was talking about the individual use cases. So supervised versus unsupervised is a question that plagues, and it requires some amount of experience before you kind of like can have an intuition when to use what. That is, so availability of labeled data is important. Also, whether you can trust the labeling that is available. Denoising of the data is important, and I was talking about this, state space, mapping, like techniques such as diffusion map, and there are other techniques. There is also this robust learning. We talked about adversaries who evade this machine learning model. So with the help of adversarial generative network, you can actually change an attack vector in such a way so that it does not get detected by the trained model. And this is, we have been able to do this for malware, and we have been able to do this for intrusion. And this is something that is that has become an instrument in the hands of the attackers. Because earlier also they used to try to evade detection by doing some things, but that had to be done kind of manually, thinking that how the detection method might be working. But with robust learning, with the adversarial generative networks, it has become automated and easy, and therefore there is a need for robust learning methods, which is robust against this kind of adversarial attacks. We already mentioned that sometimes you need online learning, especially in cyber physical context, and usability of models on edge devices. I mentioned that if you want to use it on a resource constrained device such as a phone, then how you do the model is different from the models that you do if you have more resource rich environment where your detection takes place. So cybersecurity for machine learning is, you heard quite a bit in the previous talk, so I'll not go into too much details on that. but you can imagine that somebody might try to corrupt the data before you even do learning on that, right? So data validation and data cleaning is a very important part of machine learning these days. Adversarial learning for evasion that we mentioned already, it's been successfully shown on malware, on intrusion detection, and it is coming in a big way now in the arsenal of the attackers. And then there is transfer learning model corruption. So one of the example in the previous talk was about this road sign and, where you actually have these road signs, and these road signs can be actually detected wrongly if the model is corrupted. And it has been shown by researchers in NYU that this particularly is a problematic when you do transfer learning. That if you have let's say you have a model that works for roads in US, and then you want to take the same model and do some transfer learning to retrain it for say Germany, because their road signs are different. At that point, this corruption is often possible. So that opens up an opportunity for attackers. So to conclude, so machine learning and AI are increasingly important tools for cybersecurity. Machine learning process model and methods need protection from adversarial attacks, and therefore robust machine learning is becoming more and more important. In security, there is a data deluge, right? So if you are, for example, collecting packets in a let's say a 1 giga BPS network, then in 24 hours you will be collecting about 600 megabytes of data. So 600 megabytes of data over a 24-hour period. So you can imagine the amount of data that is going to be processed, that needs to be processed if you want to do forensics, if you want to do learning from that. So there has to be ways to handle the data deluge. And then the attackers are now more poised to use machine learning to sharpen their attacks. So that's another problem that people are very worried about, that as the machine learning is getting improved in the hands of the attackers, they are getting also giving more instruments to actually do more evasive attacks and so on. So with that, I think that's something I wanted to tell you about what we have been doing in terms of machine learning and cybersecurity. So I can take questions if there are any.
May I proceed with the question?
Sure.
Good morning, good afternoon, Professor.
Sure.
My name is Dev Kumar. I am from Thadamal Chani Engineering College, Mumbai.
Okay.
You mentioned it during the intrusion detection system that how physical systems also change over time, and climate and different factors affect systems. So we need to incorporate methods like online learning.
Yes.
How can self-configuration help in self-configuration techniques help in solving these issues? Is there any work?
Self-configuration of the physical system or self-configuration of the machine learning model?
Of the physical network, physical system.
Yeah, so self-configuration or manual configuration does happen. Let's say in a power system, right? So when I was in the US, we saw work where the eastern western power. So US is divided into 3 different power system networks, grids, right? Like eastern grid, western grid, and the Texas grid. So western grid was being analyzed for detecting certain things, instability, in fact. And while doing the learning, they realized that the parameters that they learned from the data was not working in the winter. And the reason is that in the winter, the import of power from the north is different than import of power from the south. So the lines that were overloaded in the summer were no longer overloaded, and And so power system people actually know these things very well, and they actually configure their systems accordingly. It's that the machine learning model, unless the data reflects the reality, the model that is learned will be not adequate for all the time. So self-configuration or the whether it is manually configured will not matter, because eventually what you are learning is the behavior. If you have adequate data across all the different changes, then you can learn that. But if you don't have that, if you learn from a fraction of the data over a specific time, the behavior of the system at that point will be learned. So I would not know how to answer your question in terms of how self-configuration would make any difference.
All right, sir. Thank you very much.
If there are any, I think we can take one more question.
I am just interfering. Actually, now we are too late. I think it's 2 o'clock, and since 9 o'clock participants are here. So my sincere request to all of you that we will close this session right away. Thank you, Dr. Sandeep Shukla, for presenting here. And we will take a lunch break and we will join 2:30 sharp. So if you all agree, we should continue with our panel discussion after lunch. Thank you.
Thank you, Professor.
Thank you, Goza sir.
We'll be back. We'll be back by 2:30. Thank you.
Yes, sir. Thank you, everyone.
I am not sure I can join at 2:30, but that's okay. You can go ahead.
Sir, breakout rooms will be enabled after keynote, after lunch, sir?
Yes.
Okay. Thank you.
Hello.